नीचे गिरा? थैंक यू सो मच. So write down under mesomeric and resonance effect. So they are almost equal, but not exactly equal. That's the first point you should know. When I say mesomeric effect or resonance effect, they are not exactly same. There is some small difference, but as of now, at a very early stage, we can say both are same. Okay, let's not go into detail of why they are slightly different. So I'm just using this symbol, not exact equal symbol. They're almost same. Now mesomeric can be of two types, plus M and minus M. Resonance can be of two types, plus R and minus R. Okay. What is meaning of plus and what is meaning of minus? Plus means if you have lone pairs attached to a ring and it supports the ring, that's plus M. And if you have lone pair, sorry, if you don't have lone pair, let's say if you have some group which pulls electron away out of the ring, that's minus M. So first case, you are sending it inside. The other case is you are pulling it outside. First case comes in plus M. Second case is minus M. Who is plus M? This lone pair group is plus M group. And who is minus M in this? This group which is pulling electron is minus M. Is it clear? Niharika, Chenmai, is it okay? Any difficulty in this part? Any issues in this part? Very nice. Now, how will you recognize whether it is plus M or minus M? इसका बहुत simple criteria मैं देता हूँ. If you have a group which has a lone pair, it will mostly send inside the ring. I'll show you something. Let's say we have a ring like this, and I put OH, or a ring like this. Let's say put NH2. Ring like this, SH. Please draw. Keep drawing. Be a little quicker in writing today so that we can close the portions also. थोड़ा सा स्पीड में लिखोगे तो हो जाएगा. What is common in all these examples? What is common in all these examples? In all these cases, you have ring or the cyclic structure connected with some group, some element which has lone pair. So please draw. Is it clear? Adya, turn on camera, please. Adya, Niharika, and Chinmay. Is it clear, everyone? Can you observe this common feature in all of them? They have all lone pairs, right? That's a common feature. Please. Now coming to the next part. What will happen because of this lone pair? So see, due to this lone pair, we have lone pair, single and double bond formation. And this formation will be acting in this way. So this lone pair will push electron. You can create a negative charge at this place, right? Option number 1. So how will the structure look like? So the structure may look like negative charge, double O, H, plus out of 2 lone pairs, 1 is gone. I'm putting 1 plus charge. 1 plus and 1 negative is neutral. This was neutral. This is also neutral. Confirm these things. Any problem in this? Is the structure clear? So when lone pair moves here, this becomes a double bond. This double becomes negative here. Fine. And we get negative double and plus charge. Easy? Arav? Clear? What will be the next step? Next step can be, you can say this goes here and this comes out here. Negative can reach here. Next time somebody can send this negative here. So can you draw the different resonating structures which we have practiced earlier also? Can you do that? Please note down. Adya, is it clear? Okay. Any difficulty in this? Any issues in this? So in all the cases, can we observe the same thing? NH2, sulfur, oxygen, NH, sulfur, oxygen. Check all the cases. Everywhere we are doing the same thing. Everywhere there is a common feature. The group has lone pair. Isn't it simple? So any group carrying lone pair is plus m for you. बिल्कुल सिंपल कर दिया मैंने आपको. ग्रुप देखिए lone pair है तो plus m मान लेना. Plus m के ऊपर क्या हो सकता है? That's a secondary discussion. But plus m is clear. Is it simple? The group is plus m. Now see other part. Other part is this group is other than plus m. It will pull electron from carbon. See, this is carbon. This is oxygen. O is more electronegative. It will pull with minus I. Nitrogen, carbon. It will pull with minus I. Sulfur, carbon. अब सल्फर कार्बन में सीक्वेंस देख लो. फ्लोरीन, ऑक्सीजन, नाइट्रोजन, क्लोरीन, ब्रोमीन, sulfur, carbon, iodine, hydrogen. This is a sequence. So sulfur is still above the carbon. Slightly pull. Oxygen, pull. Sulfur, slightly pull. Oxygen will pull. Nitrogen pulls. Nitrogen pulls. Oxygen pulls. Oxygen pulls. Again. So, can you observe? Though they are supporting the ring, but they're pulling it away also. Pulling it towards them. I repeat. It's like giving back, taking it back. Giving and taking back. But the one which is giving is what? It is plus M. It is plus M. Positive mesomeric. And the one with which you are taking back is just minus I. अब होता क्या है? Plus M is much more bigger as compared to छोटा minus I. Small minus I. So eventually they end up giving. Okay? You give someone 10 pencils, take 1 pencil back, eventually give 9 pencils. Simple. So plus M is a huge thing. Plus M is much more important because it's coming out of resonance. Okay? Rupesh, can you just turn this from to my side? It will be easier. So plus M is perfect. Plus M is pushing inside and minus I is pulling it back. Easy. All these cases, feature is similar. I hope you understand this. Any problem, please ask. यहाँ तक कोई दिक्कत है तो पूछ लीजिए. Clear हो गया? Mesomeric effect is clear. Inductive effect is clear. So can you give me example of group which is having plus M and minus I? What will be your answer? If I ask you, give me example of groups which are having plus M and minus I. Akshay, what will be example? Can we say all OH, NH2, SHO, this, everybody is doing plus M minus I. But if I ask a question, Chinmay, give me a group which is plus M and plus I. अब क्या करोगे? Chinmay.
I'm not sure, sir.
Okay. Anyone who can answer this question? Plus M and plus I. Huh? Carbon ion. C negative. But C negative will push electron with plus M. That's a good thought. Iodine again. Iodine is anyways mild polar. So you have to find something which can push electron to carbon, right? That's how the thought is. Now write down this, and this is a very important question also. I'm highlighting it separately so that you don't forget this. Write down groups like O negative, groups like NH negative, okay? Groups like O negative, groups like NH negative. These kind of groups where you already put negative charge, they start pushing electron. Now I can say, sir, oxygen is electronegative. Why it is pulling electron? Why not it is pulling electron? Because it is O negative. So O is having not that much space where it will pull. It will start pushing electrons back. Fine. Because of this negative charge. So O negative will push electron back. NH negative will start pushing electrons back. It will pull. No. It will push with plus I. It will push with plus M also. So they are plus M and plus I group. Please make note of it. This is an important question. Everybody please make note of it. This is an important question. Clear हो गया? Niharika, is it clear? Chinmay? Adya? Any issues with this? Any problems with this part? Can we go further? Please note on the heading, write on the heading, minus M groups. Minus M groups देखते हैं कि minus M groups क्या होते हैं? Minus M groups. Can I remove this discussion? Okay. Write down minus M group. Minus M is also called negative mesomeric effect. Negative mesomeric effect, which is observed when the group is available, which is pulling electrons, right? So it should pull electrons. Now, what kind of group will pull electron? Think electronegative, and there should be some kind of bonds which can take it from there. So let's see this example. What is special about it? Please observe. Oxygen is more electronegative than nitrogen. So this pulls here and this pulls like. देखो बाहर जा रहा है. Can it send inside? There is no lone pair. It can't send inside. Can you observe the type of group, variety of group? Okay, chale. So start observing. I'm drawing certain structures. Please observe and try to answer, please, accordingly. Find out something is common in all the examples. Keep drawing. Please note down all the examples. What is your observation in all the cases? What is the common thing that you observe in all the cases? Yes, E1, E2 multiple bonds. So if I say this is our E1, this is our E2, E1, E2 double bond, and E2 is more electronegative than E1. E2 is more electronegative than E1. E1, E2 double bond. Even triple bond will also work. So I can add some examples as in this. Keep drawing. Check. In all these questions, you'll find the same feature. And the feature is very simple, very clear. It's this. Observe what I'm trying to show you. Chinmay, is it okay? Niharika, Adya? Very good. So I hope this part is pretty much clear to all of us. In all these cases, we have E1, E2 double bond or E1, E2 triple bond, where E2 is more electronegative than E1. This is always going to be minus M group, polar. Now, when it pulls, what will happen? See, when you pull in this way, what will happen? So let's say you pull it like this becomes negative, this end becomes positive. Deficient ho gaya na, remember? You pull it like this becomes negative, this becomes positive. You pull it like this becomes positive, this becomes negative. Negative, positive. This pulls, and this pulls. Check please. ये chain बन गई पूरी. Alternate double bonds. This becomes positive and this becomes negative. Similarly, this pulls, this negative. Pulls, negative, 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 negative. कर लोगे? I hope you understood this concept properly now. Plus M means support with resonance or conjugation. Minus M is pulling with resonance and conjugation. Plus I means pushing with electronegativity differences. Minus I is pulling with electronegativity differences. Done? So this much is clear. You understood plus M, minus M properly. Now I again asking the same question. Minus M and minus I group. Tell me if you have both. Minus M and minus I group. इसमें है. Is it minus I? How will you decide is it minus I? It will pull. This 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 will pull. Pull, pull. Okay. देखो देख रहे हैं minus I सब में. Everywhere you have the same feature. All the groups which I have written here, coincidentally, they are all minus M and minus I. So my next question, you can guess. What will be the next question? Minus M plus I group. क्या ऐसा कोई है जो वैसे तो माइनस एम हो बट वैसे प्लस आई भी हो जाए? अब बताइए. यस श्याम. Yeah, but that's not asking. So can there be a group which has both minus M as well as plus I? So generally speaking, this is almost null. Okay, this is almost null. We can have one or two examples we can create randomly, but as of now you keep it as null. Okay, very rare, very 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 rare. Okay, कि माइनस एम भी हो रहा है प्लस आई भी हो जाए, यानी आप बोल रहे हो कि भाई ये पुल भी कर रहा है और electronegativity is the reason behind minus M, in conjugation, and then it is pushing it back. So that's become null. Fine. These are the cases that you should know, and if it is clear, that means you understood plus M, minus M, plus I, minus M. Fine. All effects are clear up to this point. What is plus R and minus R? Plus R and minus R are exact as plus M and minus M as of now. So that difference we will discuss maybe sometime later once you are very much comfortable in organic. Then we can talk about that part. What is plus R? What is plus M? How they are small? What is the small difference in these two things? But that's not at the current point. Shall we? So if this is clear, I can move forward. Can I remove this? So in minus M cases, you're getting plus charges here, here, and here. And the same in plus M cases, you're getting minus charges here, here, and here, right? So how many of you can observe that in both the cases, you are getting charges. Let's say G is a group. Let it be plus M or minus M. You're getting charges here, here, and here. Nobody's bothered about meta position. This is called ortho position. This is meta, and this is para position. I hope you know this. Ortho, meta, para. So meta position, nothing is coming. If it is plus M, there is no charge coming up. If this is minus M, still no charge is coming up. Is it clear? But remember, if it is plus M, you are getting a minus charge here. Hence, these positions are activated to attack on electrophile. Because they are negative, they will look forward for E plus. When these positions become plus in presence of minus M group, like in this case, these positions become useless for electrophile. Hence, relatively, meta becomes better position. I repeat my sentence. If it is a plus M group, minus charges are appearing at these three places. Hence, these positions will try to involve electrophile on these places, right? But in minus M case, these positions which are marked as plus here, right? They're useless because how can plus attract plus? So the position which is not having plus becomes a better site for attack of E plus. Hence, meta becomes better. It's like, I'll give you a practical scenario. So let's say there is someone who is good in some particular sports activity and that person is not participating, and because of this, someone is getting, let's say, first. So it's basically because of absence of that, it is becoming first, right? Not because of the reason. Understand? So try to understand. In this case, meta is good for E plus, not because of its virtue or some property. It is good for E plus because others are much more bad or worse. Are you understanding this point? This is a very interesting point. Please try to understand. इस पे एडवांस का क्वेश्चन आ चुका है इसी स्टेटमेंट पे जो मैं बोला स्टेटमेंट. Meta position does not attract E plus because of its virtue. It attracts E plus because orthopara is bad. You understand the statement, please? Niharika, Adya, Chinmay. So be very careful about the statement. This is very important line. Are you sleeping properly? Why your eyes are red? Huh? But you look like very tired. What happened? Played a lot in school today. Take care of your health, everyone. Can I remove this? Akshay, written, Sanjana, Sham, Arav, लिख लिया? इधर पे चिन्मय, निहारिका, आद्या, written. Very good. तो चलिए आगे बढ़ते हैं हम लोग further discussion पे अपने. So our next discussion is, I'll just review it quickly and then we'll proceed. Now look at this diagram. I have shown OH. I have shown how charges will move. You know already. Please don't copy. You know this. You know this or not? How lone pair moves and all. So where is charge forming? This position, and this position. And you can draw the structure. Fine. You also know what are these groups. So already we understand this part. What is best for E plus attack? Plus M plus I, because it will make the ring rich. What is worse for E plus attack? Minus M minus I. Okay. Minus M plus I is rare. And yeah, that's all. Okay. Please note down this thing. VSA means very strong activator. Just write down. Very strong activator. Just draw this table. What is the meaning of very strong activator? So the meaning is simple, that if you have E plus with a plus M plus I situation, then ring is highly activated. Ring is highly activated. The ring is having lots of electron and they can easily go and attack on E plus. So we call it very strongly activated for E plus within bracket SEAR. SEAR I have done in the earlier classes. Can you recall? Electrophile आता है, H को replace करता है. Okay, benzene ring पे you put CH, CH3, CH3 in all those cases we have done. Can you complete it? Great. So this table is basically a simple summary of our discussion. And whatever we are discussing is for electrophile. You can ask, sir, why it is electrophile? Why are you not discussing about nucleophile? Because benzene ring is rich with electrons. Hence, we can talk about electrophile. Okay. So try to understand, if tomorrow somebody asks a question that you have a group like this, which is O negative, and you have E plus, let's say in format of NO2 plus, or let's say in format of CH, CH3, CH3 plus. So what is the correct placement of these groups? So you'll say, fine, these groups are electrophile, this ring is rich and all. These positions are activated, I can place any of these 3 places. Okay? Understand? The same question comes, but this time let's say they give NO2. The question comes, you will try to put it here, if possible, right? Because ortho and para position will not be used. Sajna, is it clear? Arav, is it clear? And moreover, with NO2 it will become difficult also. Maybe nothing will come because this is highly deactivated. So maybe this will not react also. We'll talk about it. Is it fine? Chal. So आगे बढ़ते हैं अपना discussion पे. Minus M is pulling electron away from the ring via resonance. I have shown you examples earlier. You've written it down. No need to copy again. So technically, you have 4 possible scenarios: plus M minus I, plus M plus I, minus M minus I, minus M plus I. 1, 2, 3, 4. Out of 1, 2, 3, 4, plus M plus I cases are when plus M plus I cases I have mentioned O negative wala case, right? Plus M plus I case was O negative wala case. NH minus wala case, right? Minus M minus I cases we have seen earlier, right? A lot of minus M minus I cases we have seen. Plus M minus I case, I said it is a rare case, right? Okay. Now, this is lone pair part. This already we have discussed. Let's not go into this. NO2. Can you just practice one structure? You want to draw or you know this? You know this, all of you? Minus and plus I is rare. Plus and minus I, we have examples, a lot of examples. Please draw one of these at least. Just draw maybe NO2. Okay. Just draw NO2. Don't look at here. Do it yourself and then check. Just for practice. I know you know this, but just for practice. Please draw resonating structure of NO2. And remember, in all the cases, I'm drawing 5 structures. 5 resonating structures. Okay. Please complete it. ठीक है? You please draw and then check. So if you remove plus comes here, then here, and then eventually you have to give it back. Normal structure. See the first one, the last one. You'll find the alternate placements of double bond. कर पा रहे हो खुद ही अपने आप? अगर कोई भी मिस्टेक आपने की है, then please do it for CN also. कोई भी मिस्टेक किया तो CN के लिए भी बना लो एक बार. कोई दिक्कत वाली बात नहीं है. Niharika, I hope you're doing this.
Yes, sir.
Okay, good. Chinmay done? Good, good, good. Very good. Can I proceed further? Anyone having any doubt? Please ask. Sham, any doubts in the bond movement? I think now you're comfortable with bond movements and all. These things you understand very well. क्या हो रहा है movements and all, because this will be required in 12th standard again. So please work upon these things. Look at for CHO. Look at for CHO. Same thing. Look at for CH double bond NH. यहाँ पे lone pair थोड़ी है, तो this will also pull. Can you understand all these structures? How I'm drawing? Look at for CO. If you want, you can please copy, just for practice. If you have any doubt, any trace of doubt, you can just copy these structures. But I'm pretty sure that you know most of the things. and you can do it yourself. I hope my assumption is not wrong. Let me just check. हो रहा है draw? Sanjana, done? So while doing it, you have to move this also here and this here. So यहाँ से इसको भी लेके आइए. अरे रेड से लिख रहे हो, ब्लू ले लो यार. Why are you writing with red pen? Okay. Done? Done, Shyam? Good. Yeah. So last one, send it here, send it here.
That's the same.
Yeah. So I think all these cases are pretty much similar only. ये ऊपर चला गया. CN, CHO. Can you find common thing in all of them? Which charge is being formed? Ortho position, para position, ortho position. Which charge is being formed? Plus charge. कर लोगे draw? Niharika, Chinmay, Adya. Can you take it as assignment or something and complete it at your own pace? These cases लिख लीजिए, नोट कर लीजिए. सेकंड केस आपने लिखा CN, थर्ड केस CHO, थर्ड केस CHO, फोर्थ केस CH डबल बॉन्ड NH, CH डबल बॉन्ड NH, फिफ्थ केस CO NH2. प्रैक्टिस करना प्लीज इनके लिए. There is no one which is plus M. They are all pullers. How do you know they are pullers? Because it's even into multiple bonds, pulling it away. Is it clear? They are all pullers. So same ही काम सब में होना है. थोड़ा बहुत बॉन्ड आप चेंज करोगे, but that's all. Rest all is same. CO NH2 लिख लिया. Okay. Now what I'm writing here is plus M groups, OP director, minus M group, meta director. I hope I explained the reason for the same and you have understood also. Anyone having any confusion, please ask. Chinmay, any doubts? Niharika, Adya in this line? SEAR reaction, E plus reaction for plus M is OP director, minus M is meta director. Any doubt in this? No doubts? Chaliye. Write the heading hyperconjugation in detail. We have to do hyperconjugation. Hyperconjugation. Point number 1 जो सबसे पहले मैं लिखवाना चाहूंगा, note down that point. Conjugation is more effective than hyperconjugation. तुम बोलोगे सर ये हाइपर है, फिर भी आप बोल रहे हो conjugation ज्यादा strong है. So don't go by the word, don't go by the English meaning of hyper. Hyper means, yes, hyper means higher, ऐसा लगता है. But hyperconjugation is not superior than conjugation. This is the first common mistake with 90% students. Okay. So first point आप लिख लो, conjugation is superior than hyperconjugation. पहला point तो यही है, basic. Now what is hyperconjugation? This is also known by various other names, by the name of the persons who found Baker and Nathan. So Baker-Nathan effect. No bond resonance. Normally we don't see a kind of bond moving and that kind of thing that is normally there in double, single, double and all. So it's called no bond resonance. This is also called sigma to p vacant orbital support. Sigma, but I'll explain you everything, don't worry. Sigma to p vacant, that's why it is also called sigma to p vacant. Conjugation is superior than hyperconjugation. Inductive effect in conflict with hyperconjugation. Inductive effect will lose, hyperconjugation will win. And the final sequence is conjugation, hyperconjugation and inductive. CHI. Okay. China याद है ना, China का CHI. हाँ. Mesomeric will be somewhere. Mesomeric is conjugation only. What is mesomeric? It's conjugation, no? It's resonance, right? Please complete this. Note down all the points. I'll explain you what is meaning of this and this. I think इसमें तो कोई confusion नहीं होगा. इसका नाम ऐसे भाई नाम है. इसमें भी confusion नहीं है. इसमें भी नहीं है. एक ही confusion हो सकता है, which is on these 2 points. And then one more point. Hyperconjugation can be of 2 types: plus H and minus H. Plus H and minus H. Mesomeric can be plus M and minus M. Resonance can be plus R and minus R. Inductive can be plus I and minus I. Likewise, hyperconjugation can be plus H and minus H. ठीक है? Minus H को बोलते हो आप reverse hyperconjugation. We'll talk about this also. reverse hyperconjugation. Next 1.5, 2 months, you have to put lots of effort because you have done everything. Now you have to just brush it up and go in 12th standard with full energy. So we should not leave any stone unturned. पूरी energy से जाना है. 11th अच्छे से यही पे complete करना है. We should not be a student की जिसने 12th में भी 11th revise कर रहा है या 11th के doubts पूछ रहा है. No, we have to finish it off here itself and then move to 12th standard. That should be the aim. So 15th March to 31st March, we'll be giving you a complete review of 11th standard. Complete revision of 11th standard. 15 to 31. Physics, chemistry, maths, all. So let's say daily one topic will be completed. Something like that. Or let's say in 2 days one topic will be completed. Okay? तो उस पैटर्न पे हम लोग प्रैक्टिस करेंगे, theory करेंगे सारी. And then further it will be taken up. Is it clear? So idea is that 1st April when you enter 12th standard, you should know everything in 11th properly. वहां तक आपका सारा रिविजन, रिव्यू, कुछ टॉपिक छूटा है, कुछ पढ़ना है, सब बता देना, सब करा दिया जाएगा. कुछ आपने मिस कर दिया, कुछ आपको समझ में कम आया, you please tell us upfront that this is the problem, we will solve it. Okay, is it clear? And then once you enter 12th standard, you should go with full energy that yes, I know everything, now things are clear. Done? Chinmay, Niharika, Adya, is it clear? Chali. So let's understand what exactly is hyperconjugation in real sense. So let's do it. Okay, let's do it. Hyperconjugation. Write few points, few more points. You've written only few points. Add few more points. This is used to explain. This is used to, or this theory is used. See, this is a theory, right? Hyperconjugation is a concept, it's a theory. This is used to explain stability of carbocations. Stability of carbocations, comma, stability of alkenes. Stability of alkenes. Okay. And stability of aromatic compounds connected with alkyl groups. Aromatic compounds connected with alkyl groups. I'll explain how and why. So I hope you have written carbocation, alkene, and alkyl group, which is like aromatic group connected with alkyl groups. So now just see. Let's say we talk about CH3. भाई थोड़ा ध्यान से समझना because I don't think कि आपने स्कूल में भी डिटेल में किया होगा. Have you done it in school in detail? Yes or no? No. तो उसको थोड़ा डिटेल में करेंगे so that ये पूरा क्लियर हो जाए कॉन्सेप्ट. एंड इसके मेंस एडवांस के क्वेश्चंस आपसे होना शुरू हो जाए. You solve any question, it should happen. Same for NEET also, right? So question should be solved. Please draw this, and we'll go very slow now. We'll go very, very slow because this is very important concept and you have no idea about this earlier. So we'll just go into fundamentals and try to understand everything properly, right? What is this C plus called? This C plus is called carbocation, or you can say carbonium ion, or we can say carbonium ion. EM is basically positive. So carbocation. Go to the next carbon. This carbon is known as alpha carbon. This position is called alpha, and this carbon is called alpha carbon. And hydrogens which are connected here on this alpha carbon are named as alpha hydrogens. So first of all, we should know the naming. Who is where? What is this called? Is it okay? Clear? Clear? All three of you? Niharika, Adya, Chinmay? Chinmay, you are there?
Yes, sir.
Okay. Now, look at this discussion carefully. Carbon is having plus. What is carbon's configuration? It is 1s2, 2s2, 2p2. Please write down. 1s2, 2s2, 2p2. Carbon is 6. This is known as ground state configuration of electronic configuration of carbon. And we know from chemical bonding, this part. This is called GS or ground state configuration. What is ES? Excited state configuration of carbon. So we say carbon will become 1s2. 2s will be having 1. And 1 electron jumps to 2p. Hence, this is the new situation. And this explains why carbon has 4 valency. These are 4 things. 4 hydrogens come, become CH4. 4 carbons come, become CC, like C4. Cls come, CCl4. Right? This is the reason behind carbon's 4 valency. ये सबको पता है? इसमें कोई doubt? Now see, this carbon is a special carbon. This carbon has a plus charge. Plus charge means one of these electrons is removed or it is not there. ये वाला नहीं है. यानी अब situation क्या है मेरे पास? ये. Okay. So I'm saying this is a C plus situation. Are you understanding? एक electron उड़ गया है ही नहीं. So this is the case. Can I say this is indicating a vacant orbital? This is indicating a vacant orbital. Which orbital are we talking about? 2p. Now 2p can be x-axis, 2px, y-axis, 2py, z-axis, 2pz. Now, let's say I consider that one of the orbital is vacant. It can be in any direction up to your choice. I can draw it like this. It's a vacant orbit. Now come to other side. This is a carbon-hydrogen bond. What kind of bond is this? So this bond we normally call sigma bond. In the language of chemistry, we call it sigma bond. Sigma bond, if you recall, remember this question, if I give you C double bond C, HH, HH, this is sigma, this is sigma, this is sigma, this is pi, sigma, sigma. So in double bond, 1 sigma, 1 pi. We know this, right? So this is a sigma bond and this is a vacant orbital. Can you observe this much and please draw this much? Write down this, write down this. यहाँ तक पहुंच जाओ. नोट कर लिया? यहाँ तक पहले आप नोट कर लीजिए, समझ लीजिए यहाँ तक पूरा. How many of you remember back bonding from chemical bonding? Chinmay, what is back bonding from chemical bonding? Can you answer, please? Chinmay, can you hear me? Please answer, what is back bonding? Unmute and answer.
Sir, back bonding is hydrogen bonding within the molecule.
Hydrogen bonding is different. Back bonding is different. Have you done back bonding?
Yeah.
What is back bonding?
Vacant here.
So back bonding, in short, if I just quickly revise it in this small box, write down back bonding. Back bonding is second and third period members, one having vacant orbital, other having lone pair. Lone pair supports vacant orbital. Can you recall? This is called back bonding. Examples were BF3. Fluorine supports boron in vacant orbital. Because of that, the BF bond becomes shorter. We have done these things or not? Can you recall? Or example could be, there can be many examples, right? Let's say another example can be N with 3 SiH3. 3 SiH3. These electrons are dragged in vacant orbital. Hence, lone pair is absent. Hence, it is trigonal planar. Can you recall these examples? This was back bonding. Don't you think that something like this is happening here? You have a bond, you have a vacant orbital. The only difference is you don't have a lone pair. Had it been lone pair, you would have formed the permanent bond. Since there is no lone pair, there is just presence of electron, which is due to sigma bond, and there's a vacant orbital. We can't shift it completely and say, okay, take it. Is it clear? So what happens? What is hyperconjugation? Hyperconjugation is a phenomenon which shows or which describes stability of these carbocation with effect. Just draw this. So what I've done, I've taken the sigma bond to P, which was vacant. I've taken a sigma bond to a P. This is your P vacant. And this is known as hyperconjugation. So ये question IDJ का question है. Options were given sigma to P vacant, pi to P vacant, pi to pi, sigma to sigma. ऐसे 4 options दे दिए random उन्होंने. Which option will mark? Sigma to P vacant. This is the actual IDJ question. Once you solve PYQs, you'll come across this question. So sigma to P vacant is called hybridization. Now what will happen because of it? Because of it, can I say this carbon, hydrogen, you get a double bond here, hydrogen, you get this kind of alkene. And this H who is losing electron will be in the closed vicinity of the compound. So this is represented as this. Remember, you cannot run away with this H plus. You can't take it out and अरे हो गया ये H plus निकल गया. ऐसा नहीं कर सकते आप. This theory is just explaining the stability of carbocation. It does not say that this H is acidic or something. I repeat my sentence. It does not conclude as this H is acidic. Is the statement clear? Shyam, okay?
So it stays in that compound.
Yes, it remains in the vicinity of the compound. Just write down this word. This H plus remains in the vicinity of compound. You can't take it and run away. Very important point. बहुत से लोग इसको acidity समझ लेते हैं कि अरे वाह कार्बोकेटन दिए चलो H निकाल के भागते हैं और एक एल्कीन बना के दे देते हैं आंसर में. नहीं होगा. It is not possible. Niharika, is it clear? Adya, Chinmay? Very good. So I hope this part is now pretty much clear. Should be okay. So in this case, how many such hydrogens do you carry who can have this capacity or capability? One is this. Of course, other can be this. And third can be this, right? These three are equally placed scenarios. These are all same, right? अभी ऐसा कुछ special थोड़ी है H में जो इसमें नहीं है. या इसमें नहीं है. All are same, right? So for that matter, you can take any of the H. So we can say that we have got 3 alpha hydrogens which can explain the stability of this carbocation. This is what is hyperconjugation in simple words. Is it clear now? Now, next time if I give you any alpha H, you have to just count and you can talk about the stability of carbocation. And this first part will be taken care of. Is it okay? Can I remove this?
Does number of alpha have significance, like more alpha H's or more stable?
Yeah, I'll come to that. That is the next discussion. Any problem with this part? Anybody? Any issues? Can I remove this? You've written, all of you? Good. So, chali, थोड़ा सा इसको और detail में समझते हैं. So, let's say a question comes when you have C plus and you have CH3. With respect to this carbocation, please count alpha carbon. So, give me alpha carbons, how many? Give me alpha hydrogens, how many? Next question, C plus CH3 hydrogen. Same question. Alpha carbon, how many? Alpha hydrogens, how many? Next question, C plus just CH3, 2 hydrogens. Alpha carbon, how many? alpha hydrogen how many? And the last case, C plus H, H, and one more H, alpha carbon how many? Alpha H how many? And then C plus C CH3, CH3. Alpha carbon. Count and write quickly. Be real fast. Note down and then write. Copy the question first. अभी बहुत अच्छा लग रहा है, बाद में सब भूल जाते हैं, इसलिए please note कर लो. Please note down. No compromise on your notes. लिख लीजिए please. अक्षय जी note करिए सारे cases. And then write alpha carbon and alpha hydrogen. किसी का solve हो गया? Anyone was solved? On board. How many? सुनाई 0. बैठे. Any changes? If any changes, you can cut and write your answer next to that. Any other changes?
Yes,
Any changes? आरव वो खो गया अभी. क्या चल क्या रहा है ऐसा? Okay. Any changes? Niharika, Chinmay, Atya.
No, sir.
Do you agree with the change which Shyam has done? Shyam has made some correction. Do you agree
Yes.
with that? With respect to this plus charge, we have 1, 2, and 3 carbon. Don't count this carbon. This is beta carbon. ये alpha है, अब beta चले गए. Is it clear? Alpha ये वाला हो. And there is no hydrogen because I have replaced all the hydrogen by CS3. So this is correct. 3 and 0 is correct. I hope this question is fine. Now please take a short break, not very long break of 10 minutes, and we continue at 3:15 sharp. Welcome back. So we can count alpha hydrogen, we can count alpha carbon. Niharika, Chinmay, Adya. ऑफलाइन वाले आ गए, ऑनलाइन वाले क्या? तीनों ही गायब है। हाँ, इट्स ऑलरेडी हो राइट। हाँ, 317। चिन्मय, निहारिका and Adya, can you hear me? Chalo, let's start then. So if you see, the one which is having maximum number of alpha hydrogen will be the most stable. Then second, then third, then both are zero. So they will be like fighting for fourth placement. Now, which is worse? This one is bad or this one is bad? How do you decide? Now, this is very bad structure. Why? Because on C plus you are putting so many groups, which is a good amount of, there's a word used for it, steric crowding. Steric crowding, note down. Steric crowding means lot of traffic basically. So due to this, this plus charge will be highly unstable. You're putting so many CH3s like this, it will make the whole system unstable. So ये worse चला जाएगा, इससे भी ज़्यादा, ठीक है? This one is best. 1, 2, 3. Okay, because of 9 alpha H. So alpha H is the guiding principle for stability of this. More alpha H, more hyperconjugation structures. No, vacant orbital is one only. More H can support. This can also support. This can also support. This can also support. That's what we discussed before break.
Okay, thanks.
Yeah, same thing. C plus.
I got it.
Can I recall this? Okay. So this is the first case which is telling you about carbocation stability. Chinma, are you back? Now coming to the next case. इसको पहले एक बार नोट कर लीजिए. Can you proceed further? चलिए आगे बढ़ते हैं. So I'm removing it, considering that you understood this. So quick review of hyperconjugation. This part is clear. This is also clear. How do we count alpha H? That part you understand. Now I'll come to the double bond part, but before that, this is also clear. This is more stable in the sequence. This kind of question, 6, 3, 2. 3 is better than 2. Remember, this is ethyl group, but methyl becomes better. Normally, inductive effect will say ethyl is better. So this is a fight between inductive and hyperconjugation. Inductive says this is better. Hyperconjugation says this is better. Who's the winner? Hyperconjugation. So actually, this is better as compared to the previous. Is it okay? Please note on this example. And then we go to these kind of questions you can easily answer now. How many alpha H are there? Should not be a problem for you. Then I'll come to stability of alkene after this. Please note down this. Then I go to stability of alkene. Complete this. Note these examples. Clear, Sham? How was your score this time in chemistry exam? All of you. Out of how much it was? 25. कितना स्कोर किया था? भूले तो नहीं होंगे? ऐसा बोला कि मैं भूल गया. What was the score, Sanjana? 19. आपका अक्षय जी? 17. 18. 17. इधर ऑनलाइन वालों के क्या नंबर थे केमिस्ट्री में? भूल गए या याद है? या आवाज नहीं आ रही? आवाज नहीं आ रही. चलो कोई बात नहीं. ठीक है, कोशिश करो कि इसको इम्प्रूव करो. पेपर वॉज डिफिकल्ट. 25 क्यों नहीं है किसी के? 25, 24 क्यों? डिफिकल्ट था पेपर.
No one got it.
What is the highest? Who?
Top sharing, sir.
Okay. Done. Any doubts in this? Can I go proceed further? चलिए लिखिए next. Stability of alkene. Yeah, this is 2 alpha hydrogen. This is 3 alpha hydrogen. No, alpha. This is beta. So 2 and 3. So I'll mark this as better. But as per inductive effect, this is better. Okay. Because ethyl inductive effect is considered better as compared to methyl effect. But who's the winner? 3 alpha H. Hyperconjugation. Whenever there's a conflict between hyperconjugation and inductive, the winner is hyperconjugation. यही सीखा हमने, right? Chinmay, are you back now? बहुत दूर निकल गया लग रहा है. चलो, let's see whether he's back in the class. Anyways, coming to the next part of the story, that is alkenes. Yeah, एक बार check कर लेते हैं. Can you hear me, Niharika and Aditya? So what was the score in chemistry, if you can hear me? अभी नहीं सुनाई दे रहा. Okay, चलो. Let's not disturb them. Write down stability of alkene. This is second application of hyperconjugation. लिखिए. Second application of hyperconjugation is stability of alkene. You can tell about stability of alkene. So now, first application was the previous one which you have done, stability of carbocation. So let's say we have these structures. Please draw. And थोड़ा speed में draw करने की कोशिश करो. Calling it 1, 2, 3, 4, 5, 6, and 7. Please draw without mistake. कुछ गलत मत draw कर लेना. Chinmay is back. What happened, Chinmay? Where were you?
So I was here, I forgot to turn my camera on.
Okay. Please note down this. Done. So just see the first example, for instance, or let's say we can take this one. If you give it H plus, how will it look like? If you give it H plus, it will become H plus CH3, H and hydrogen. That can be one option. Or it can be H These are the two probable options. Please draw. These are two probable options. या तो यहाँ पे प्लस चार्ज आएगा, H इधर आ जाएगा, यहाँ पे प्लस चार्ज आएगा, H इधर आ जाएगा. यही तो हो सकता है, दो ही चीज हो सकती है. Now please tell me, out of these two structure, which will give you more hyperconjugations? If you see this structure, this is alpha carbon, there are two alpha H. And look at this structure, this is alpha carbon and this is also alpha carbon. That way. Can you observe? So which position is better position for plus charge? This position. ये भी आप इससे ही तो बता सकते हो easily, right? So when you discuss stability of carbocation, you can again take help of this method while deciding it. That's one criteria. Is it okay? How much you understand this logic? What I'm trying to convey? Second important thing. If I consider the C double bond C as a pi orbital, right? And let's say you have a CH here. Out of 3 CH, I'm drawing it like this. So this is a sigma and this is a pi. And when you want to discuss any kind of hybridization in this, what is the possibility? Possibility is if I break this bond, keep negative here, keep positive here, I can again talk about hyperconjugation. Because when a double bond breaks as a minus and plus, the plus and the next carbon with alpha hydrogen, we can talk about hyperconjugation. This is how we can talk about hyperconjugation for this particular scenario or stability of alkene. So if you see this C double bond C, these are my alpha carbons and these are alpha hydrogen. So 3 plus 3, 6, 3, 9. If you see this one, 3, 3, 6. If you see this one, 6. This one, 3 and 3, 6. This one, just 3. This last one, 0. And the first one, 12. Do you understand this? This is how we count alpha hydrogen. So you have C double bond C. You'll go to this position count and you go to this position and also count. Both sides you're counting. इधर का alpha ये मिला और इधर का alpha इधर मिला. Is that clear? Chinmay, Niharika and Adya, is it clear? How do we count alpha? And logic behind is also clear because we can give H one side and give H other side. So out of 1, 2, 3, 4, 5, 6, 7, if you have written all of you have written 1, 2, 3, 4, 5, 6, 7, which is most stable alkene among these? Your answer would be 1 better than 2, better than 3, better than 4, better than 5, 6, 7, 8 and 9. Now this is the order of stability. Please note down. Question comes why and how? Because 12 is bigger than 9, understandable. 9 is better than 6. 6 is better than 3. 3 is better than 0. That's okay. But how will you decide this 6, and this 6? That can be a key question here. These all are 6. So how I'm telling that 3 is better than 4 is better than 5? This is the problem area. Yes or no? Because all are 6. How are we deciding that 3 is better than 4 is better than 5? Because in 3, if you draw 3 carefully, you can get this possibility. So see, all 6 alpha H are present on same carbon. Hence, it can form a 3-degree carbocation. Are you understanding? That means its hyperconjugation is more stable as compared to other two, where one will be 3, other will be 3. I'm counting 6, but this is 3 and 3 separate. This is 3 and 3 separate. This is 6 together on the same carbon. So I hope this is clear that this 3 is better than 6 together is better than 3 plus 3. अब क्वेश्चन आता है why 4 is better than 5? Because 4 is trans. Trans senses आपने पढ़ा हुआ है? Trans is more stable. Trans is more stable. The reason is this is having diagonal symmetry. CH3s are away from each other. They will not create any repulsion, hence become stable structure. Okay. So trans के लिए क्या क्या चीजें अच्छी होती है? नोट कर लो एक बार फटाफट. Trans के लिए क्या क्या better है? Trans has better what? Tell me. Let's. Trans has more symmetry. Note down. Trans has more symmetry. Trans has higher melting point. I repeat, trans has more symmetry. Trans has higher melting point. Trans will have lesser boiling point. चलो इसको mix मत करो, confuse हो जाओगे. Just write higher thing first and let other one I'll write for the other high, right? So trans has more symmetry. Trans has more melting point. Is that okay? Now coming to cis. Cis has more boiling point. Cis has more boiling point. More dipole moment. More boiling point. More dipole moment. Okay. Now I hope you understand the whole thing. If symmetry is more, dipole moment will be lesser because symmetry will cancel out moment. Yes or no? Symmetry will cancel out dipole moment. So symmetry is more means dipole moment will be lesser. So trans is a non-polar compound. This is a polar compound. So I hope this is now clear why 4 is better than 5. The sequence is clear. If you know the sequence, can I say this is most stable alkene? If a question comes in exam, which is least stable alkene, what should be your answer? Write down. Write down.
Yes.
Ninth one is least stable alkene. Oh, sorry, seventh. Seventh one is least stable alkene. Seventh one is least stable alkene. One more line for seventh one. Seventh one is most reactive alkene. Least stable और most reactive बहुत पूछते हैं एग्जाम में. कंफ्यूज नहीं होना आपको. जो least stable होगा वो more reactive होगा यहाँ पे. Is it clear, चिन्मय? चिन्मय आज थोड़ा इधर उधर ध्यान है इसका, कुछ तो कर रहा है अलग एक्टिविटी. What are you doing, चिन्मय? Other than study today, what are you doing? Normally in class you are very focused, but today I cannot see focus.
So I'm just tired.
Okay. Okay. Fine. So what I was discussing?
The most, yeah.
Yes. So ninth one is least stable alkene. Ninth one is most reactive alkene. ये भी एग्जाम में क्वेश्चन आ सकता है आपसे. And this is of course least reactive alkene because most stable alkene है. ये रिएक्शन में पार्टिसिपेट नहीं करना चाहेगा जल्दी. ठीक है. अब एक और चीज बताओ. Have you heard of term heat of hydrogenation? अरे थर्मो में पढ़ाया, सीधे मना कर दिया इसने. थर्मो केमिस्ट्री में पढ़ा है ना, हीट ऑफ हाइड्रोजनेशन, हीट ऑफ कंबशन, एंथैल्पी ऑफ हाइड्रोजनेशन. Yes or no? Enthalpy of hydrogenation सुना है? Delta H सुना है hydrogenation? That is heat of hydrogenation. Hydrogenation means what? When double bond becomes single. Thermochemistry में किया, we have done all this thing, right? Hydrogenate करते हो आप, C double bond C से C single bond C ला रहे हो, right? That is hydrogenation. Double becomes single or triple become double. Now tell me, enthalpy of hydrogenation is maximum for which case? Magnitude wise. बताइए. पहले तो होता क्या enthalpy of hydrogenation, एक बार रिव्यू करा दो. First you have written this down. Can I remove this? I'll come to that. Can you recall 1, 2, 3, 4, 5, 6, 7? I'll not draw again. I'll just do it. Right. I'm removing it. So let's take this example. The 1 and 7. Just दो ही बनाते हैं, बाकी आपको याद है. This was your 1 and this was your 7. लिख लीजिए. Now the question is heat of hydro or enthalpy of hydrogenation. Now first thing you have to understand is what is hydrogenation. Write down one line for it. adding 1 mole of hydrogen, to unsaturated gaseous molecule. The amount of heat released is called enthalpy of, or we can say heat of hydrogenation, right? The amount of heat released is called enthalpy of hydrogenation. Basically, if I write CH2, double bond CH2, in gas form, you add H2, gas form, you get CC, single bond, and all hydrogens like this. This process, whatever amount of energy will come out is called enthalpy of hydrogenation. Hydrogen, adding 1 mole of H2 gas on a given gaseous molecule to convert double bond to single bond or unsaturation to saturation. The amount of energy involved is enthalpy change, delta H. Now delta H, mostly it will be negative for it. Okay. Now think, had it been stable, if ये stable होगा, online people, if it is stable, to break this, you need more energy or less energy? Answer. Chinmay, if it is stable, to break this, you have to spend more energy or less energy?
Sir, it takes more energy to break a stable bond.
Yes. So let's say earlier this was minus 100. I'm making it more stable somehow by changing groups and all. Let's say 50 I'm wasting in just breaking this bond. So the value will come down to 50 only. Let's say later I'm spending 80 here. So value will come 20 only. If I'm spending 90 there, the value will become 10 only. Is it clear, Shah? Are you understanding? So now the question is bigger and smaller. So I'll consider sign, with sign. With sign, this number is bigger. Minus 10 is bigger than minus 100 mathematically. But whenever you talk about heat of hydrogenation, generally the meaning is only magnitude. I repeat, only magnitude, not sign. ये इसका general meaning होता है. Ideally, examiner should be clear. They should clearly give you that with sign, without sign, what they want, but they will not tell you. Trust me, 90% cases they will not give. So you should know that only magnitude you have to consider. Basically, you will say this 100 is better than 10 if this question comes. But if this question comes, enthalpy word is coming, it has to be with sign. अगर इसके बाद भी कोई sign use नहीं कर रहा है, तो वो गलत कर रहा है. That person is wrong. Then this is my answer. कुछ समझ में आया? Again, this is a very common confusion. I'm again repeating the sentence. Adya, are you understanding this point? Niharika? I'm coming to that. Enthalpy of hydrogenation is delta H reaction is summation of product minus summation of reactant. यहाँ से आपको enthalpy में, right? But when you say heat of hydrogenation, it is just exchange of energy. We don't bother about minus or plus. So heat of hydrogenation is little tricky. I will suggest one simple thing. This is more reactive or less reactive? More reactive. No, this C, double bond C. This is less stable. This was less stable and it was more reactive. Since it is less stable, can we say in this case, maximum amount of energy will come out? Agree? क्योंकि सबसे कम stable है तो इसको break करने के लिए कुछ लगा ही नहीं, आराम से reaction हो गई. Whereas in this case, energy will be consumed, hence energy release will be lesser. Are you understanding this or not? So अब मेरे को आंसर बताना प्लीज. अगर मैं बोलूं HOH and delta H, तो HOH का आंसर बता दीजिए पहले. 1 और 7. HOH max, HOH min, बताओ. मैक्सिमम हीट ऑफ हाइड्रोजनेशन किसके केस में मिलेगा? फिर से सोचो. मैक्सिमम हीट ऑफ हाइड्रोजनेशन किस केस में मिलेगा? हीट ऑफ हाइड्रोजनेशन मैक्सिमम कब होगा? जब ज्यादा एनर्जी निकलेगी. एनर्जी ज्यादा कम निकलेगी जब कम वेस्ट होगी. कम वेस्ट कब होगी? जब ये कम स्टेबल होगा. नो, हाँ 7, करेक्ट, 7. एंड दिस केस डेल्टा एच, ठीक बोला, करेक्ट. इधर मिनिमम में 1 and 7 आ गया, नोट कर लीजिए.
increase the heterogeneity side.
Exactly. Enthalpy is with sign. That's what I have written here. It has to be with sign.
That magnitude is the same now.
It is the same thing, same magnitude. With us, just sign is there and sign is not there. Yes. Whatever I have told is also applicable for another term called combustion. Combustion क्या होता है? Burning with oxygen. So as you do hydrogen reaction, same as burning with oxygen. An alkene which is less stable, more reactive, will burn quickly, easily, will release a lot of energy. Its delta H will be minimum. Delta H will be minimum. And maximum HOH. Are you understanding? Whereas vice versa for the same. So hydrogenation और combustion दोनों में आप same काम चल सकता है and दोनों के answers आप कर सकते हो. Is it okay? Chinmay, Niharika and Adya, is it clear?
Yes, sir.
All right. Please complete it, then we proceed further. Done? लिख लिया आप लोगों ने? Can we proceed further? चलिए आगे बढ़ते. So now just quickly see here. Heat of hydrogenation term is clear. ये सब मैं आपको discuss कर चुका हूँ. Transes and all. Stability of alkene 1, 2, 3, 4, 5, 6. You know reactivity other way around. Carbon ion. Write down the heading carbon ion. Carb anion. Carbon ion मतलब C negative. फटाफट नोट करना, इसमें कुछ ज्यादा समझाने का नहीं, मोस्टली आपको चीजें पता है. C negative intermediate is called carbon ion. We have 3 sigma bond with 1 negative charge. Carbon is sp3 hybridized. There will be 3 sigma and 1 lone pair, so sp3. C minus is stable if I put something which can reduce this negative charge. You know that. You have to put something which can reduce the negative charge, right? Because anyway, be it plus charge or be it minus charge, you have to reduce in both the cases. You have to make it stable, electron withdrawing group, you have to keep to reduce the negative charge. That is how things work. And I hope that is very much clear also. Any problem? Anything new in this? It's all you know already. कुछ नई बात तो नहीं कर रहा हूँ? Chinmay, Adya, Niharika. Anything new in this? I think this already we know. We have understanding of this part. Quickly note down these pointers. Can I proceed further? So if I say CF3 minus and CH3 minus, which is more stable? If I say CF3 minus and CH3 minus, which is more stable? CF3 minus. Because fluorine pulls. If it pulls, minus charge will come down. If you have CH3 minus and CH3, CH2 minus, which is better? CH3 minus is better. Because CH3 pushes electron. If it pushes electron, it will increase negative charge. सोचो, negative charge is collection of water, condition of flood. ऐसा समझ लो, just for correlation, to like connect your brain in such a way that you can think quickly, right? So negative charge means, let's say water is electron. Negative charge means what? A lot of water. खूब सारे इलेक्ट्रॉन है वहां पे, तो क्या करोगे? वहां पे ऑलरेडी माइनस चार्ज है. आप बोलो वहां पे 2-3 नदियां और भेज देते हैं, send 2-3 more rivers. Flood situation already problem. You have to pull. This is better. This is not good. Is it okay? If it is a plus charge, deficiency of electron, deficiency of water, drought condition, you have to supply water. Don't say that drainage is not ready. Flash flood आ जाएगा. तो वो उतना भी नहीं ज्योग्राफी में जाना है। See, अब ये देखो यहाँ पे इंपॉर्टेंट चीज है, एल्काइल ग्रुप इज अ प्लस आई ग्रुप, यू नो दैट। अब यहाँ पे प्लस आई माइनस आई प्लस आई माइनस आई इसीलिए किया हम लोगों ने। CH3 is a plus I group. Plus I means it's a pushing group. No, this will push electron. This will push. There's a minus charge. So minus charge is already there. You are pushing electron. You are sending reverse. So it will increase. That's why it is poor structure. This is better structure. Is it okay? Next, if you have this question, can you solve this question? Negative charge CH3 is better than CH3 with 2H with better than 2 CH3 than 3 CH3. Had it been plus, exactly reverse answer. Now let me ask a question here. अभी कल ही कोई पूछ रहा था, कहीं पे तो डिस्कस हो रहा था किसी डाउट सेशन में. If I give you a question, you have CH3, CH2, CH3. It is breaking heterolytically. Heterolytically, you understand? One will get plus, one will get minus. So how shall I break? Shall I keep plus here, minus here, or shall I keep minus here and plus here? Option A or option B? Think and answer. Don't be in hurry. A or B? How many say B? Raise your hand. How many say B? Raise your hand. How many say A? Raise your hand. Answer is B. Why? Because I will prefer minus charge here because it's CH3, and I'll put plus charge here because that's a stable situation as compared to CH3 getting a plus and CH2, CH3 getting a minus. Because this CH3 is a plus I group, will increase the minus charge. Here the plus charge is there, CH3 will support with plus I, will reduce the plus charge. Is it clear? That is the application of the same concept which you are learning right now. Is this question clear? Niharika, understood this point? So if you break heterolytically, how will it break? Adya, is it clear? Chinmay? Clear? Okay. चलो आगे बढ़ते हैं फिर. Now benzyl and allyl, these words we have done multiple times. Benzyl क्या होता है? Benzene ring and CH2. Allyl, CH2, CH double bond CH2. We have done it or not? Number of times. So benzyl and allyl are reasonably good carbon ion also. Okay. Why? Because minus charge can disperse like this. Okay. Check this example. Minus charge can disperse like this. Easy. Doable. Great. कर लीजिए. Note down these 4 questions. We have done it number of times. Again, I will just revise, quick review, and then we close it. Answer. Note करिए. Any doubt? CF3 minus and CCl3 minus. Why CCl3 minus is better? Sham. No, fluorine is molecular FONCl. Chlorine has vacant d orbital. It's a back bonding example. Minus charge dragged in the vacant orbital of chlorine. So right now, it is stable because of 2p pi, 3d pi back bonding. Note down this example. First one. First one का reason हो जाएगा back bonding. Back bonding की वजह से क्या हो गया? ये stable हो गया. Of course, back bonding is a strong support. What about second question? Second question में उल्टा लिख दिया मैंने CF2 CCl2 by mistake. नहीं, ये सही है. Why it is now this way? Can you explain? Why second question this way? बताइए. सोचिए थोड़ा सा. तीनों चारों क्वेश्चन के आंसर आप खुद प्रिपेयर करिए. शरण नहीं गए? शरण नहीं गए? शरण नहीं कब गए? अच्छा. अच्छा. ठीक. हाँ. अच्छा, तो वो उसमें आ गए होंगे. हाँ. Which one?
CF2.
So what will happen? That's my question.
Because in the case of CL will try to take the load pair.
Very good. Good observation. See, in case of this negative charge is to be pulled. Now, in this case, you pull with minus I. And in this case, you drag with vacant 3D, which is back bonding, 2p pi, 3d pi bonding. In this case, this carbon is deficient. It has a vacant orbital. Now, this time it needs support. This support comes from a 2p and this support comes from a 3p. So, which is a better support? 2p support is better than 3p support because carbon is also a member of 2p. So 2p pi is better than 2p pi, 3p pi because this is same energy level. Is it clear? ये दोनों बहुत बार एग्जाम आ चुके हैं. एटलीस्ट अगर एग्जाम आप चेक करोगे 10 बार आए हुए दोनों क्वेश्चंस. ओके, रिवर्स होते हैं, बार बार बच्चा फंस के गलत करता है. एक बार समझ लो इसको प्रॉपर्ली. इज इट क्लियर? So CCl3 minus is better or more stable than CF3 minus, whereas CF2 is better than CCl2. Now, what is CCl3 minus is better carbon ion. So can I say CHCl3 is better acid than CHF3? Isn't it? भाई आप H निकालोगे, माइनस चार्ज बनाओगे. So माइनस चार्ज स्टेबल हो रहा है मतलब क्या? H निकालना इजी है. So can I say this denotes this? Or this, the reason is hidden here. This is reason. Understand? And CHCl3 and CHBr3, why CHCl3 is better? Adya, can you answer this? CHCl3 and CHBr3, why CHCl3 is better? Better acid. CHCl3 is better acid. Stronger acid. Why? Negative charge on carbon. In both the cases, 2p pi has to be driven in chlorine's 3d orbital and bromine is in 4d orbital. So 4d with the gap और बढ़ गया. Is it clear, Adya? This is 2p pi 3d pi and this is 2p pi 4d pi. After removal of H, minus charge is there. You are sending it where? You are sending it to bromine's vacant orbital. So 2p 3d and 2p 4d. 2p 3d is better, right? I hope you understood all 4 questions. Niharika, is it clear? Chinmay, is it clear? Okay. Clear? Now come back. So back bonding, already we understand. These examples we understand, CCl3, CBr3. Okay. Now look at this example. It's a 3-degree benzylic. This is called 2-degree benzylic. This is called 1-degree benzylic. Ring is a CH2 minus, 1-degree benzylic. There are 2 rings. That's why I call it 2-degree benzylic. Benzylic means benzene rings connected with CH2. It's called benzylic. If I put minus, it's benzylic carbon, and if I put plus, it's benzylic carbocation. If I put radical, it's benzylic radical. All are stable in their categories. Okay. Benzyl, allyl are good in their categories. When I say their categories, as in if I compare carbocation with another carbocation and you have benzyl carbocation, it's better. It's preferred as a stable one as compared to other cases. Is that okay? So this example is clear. In this case, minus charges dispersed in all 3 rings. In this case, just 2 rings, and in this case, just 1 ring. So who's better? This is better. Note down. कुछ examples है फटाफट लिख लीजिए. Likewise, 3-degree allylic is better than 2-degree allylic is better than 1 degree. Likewise, 3 degrees better than 2 degrees better than 1 degree.
The same.
Yeah, same thing in benzyl also. You want to see 3-degree allylic? It's like this. Negative, इधर भी double, इधर भी double, इधर भी 3 हो गया ना? 1, 2, 3. 2-degree allylic, this. 1-degree allylic, just 1 member. Easy. So पहले इसको नोट कर लो. एक-एक करके लिख लो. पहले इसको लिख लो, फिर उसको लिख लो. Complete this. Allylic, you understand? CH2, CH double bond, CH2. CH2, CH double bond, CH2.
Maybe this. Yes, sir.
Hmm?
Load to the end of class.
You've written?
Okay. Order.
Okay.
And got the
Okay, fine. Let's not go into that. Okay, good. So, have you done these questions also then, by any chance? No. You did this also? Okay, just write on this one by one. Let's write on this. CF3COH and CCl3COH. This is better acid. Why? CF3COH and CCl3COH. Why it is better acid? First of all, let's do one thing. Let's do it in detailed way. Let me just get it directly first to acidity, basicity, fundamentals. Then I'll come back to this. Write on the heading, acidity and basicity. Acidity and basicity. Clear? What is acid? Acid is something which furnishes what? Furnishes H plus ions in solution. Yeah, this is called arenous acid. Now there are other type of acid which is electron pair acceptor. जैसे कि आपने बोला अभी AlCl3 या BF3. Okay, these are called Lewis acid. Then there can be other case, ammonia. Let's say becoming H plus and NH2 minus. Now ammonia normally is a base, but now if it is giving you H plus and NH2 minus, it's basically the theory is called relative acidity basicity. It's called Lowry-Bronsted acid. Okay, so it's like, let's say you have two bases, but one base is more basic. So the one which is less basic is acidic. I repeat my sentence. You have acid and base, this is acid, fine. But when you have two bases, one base is more basic. So the less basic is acidic. That is the concept given by Lowry and Bronsted, concept of relative acidity and basicity. Okay. So there are three theories, or three, at least there are more than 10 theories, right, in acidity basicity only. There is something called hard acid, soft acid, hard base, soft base. We'll do somewhere in inorganic. But at least three theories you first understand. First is arenous acid, based on H plus, who's giving H plus is arenous acid. Second, electron pair acceptor, Lewis acid. Third, relative acidity basicity, same member ammonia, which is a base, is acting as an acid in presence of an even stronger thing which can take its electron, or takes its H plus, right? That's called Lowry-Bronsted acid. Yeah, in this case, NH3. Is that okay? So if I give you this example, CH3 MgBr with NH2H, NH2 is losing its hydrogen, CH3 is becoming CH4. Can I say NH3 is acting as an acid for this reaction? CH3 minus is capturing this hydrogen, becoming CH4. Ammonia is losing its hydrogen. So can I say ammonia is acting as an acid? Yes or no? For this particular case, note down. It is releasing H plus. It is losing H plus. Just note down these cases. First case, second case, ammonia acting as a base. Ammonia takes H plus. Base हो गया. Next case, acting as a base, water. Water taking H plus, becoming H3 plus. Base can capture H plus. Acid can give H plus. Fine. So what are basic definitions of acid? One, you can say acid which gives H plus, acid which takes electron or lone pair, acid. Okay. If it is base which takes H plus, which gives OH minus. यहाँ पे क्या कर सकते हो? Which takes OH minus भी पूछ सकते हो. And which releases, which gives electron. Okay, that's a base. Fine. So is this example clear? Adya, Niharika, and Chinmay, is it clear? Is next example clear? Ammonia with HCl. Ammonia is grabbing hydrogen, hence acting as a base. The one who takes H plus is a base. Next example, water HCl. Water is grabbing H plus, so it's a what? It's a base in this case. HCl is an acid, losing H plus. Ammonia and water. Now water is acting as an acid. Because what's your answer? NH4 plus and OH minus. Water is losing hydrogen. समझ में आ रही बात? So same water with ammonia and same water with HCl have different standards. In one case, when you bring HCl, it absorbs H plus. In other case, when you bring ammonia, it gives H plus. What do we call this kind of groups? Amphoteric. The word is amphoteric. Okay, amphoteric, as in it can take, it can give, either way it can. Fine. So I'll not extend much. Already we have done a lot of things here. So we'll continue with this discussion in the next class. Just remind me that we have to do this small segment. Anybody can take note of it, that we have to do substitution free radical. Substitution free radical. Just this much note so that we can complete it. Okay. Done. Next class is 5 o'clock. So you can stay here and continue, or you can go home and continue. 5 to 7 is maths, right? 5 to 7 is 7 to 9 aaj.
So is it only for the week?
Only for this week. Next week, chemistry or physics will come.
Okay. Like you can keep after 6.
Okay, we'll try.
Yes, the same.
आज का बस मैनेज कर लो आप. Bye bye, Chinmay, Niharika, Nadia.
Thank you, sir.
Thank you, sir.
I hope you understood everything. Okay. Greetings everyone, welcome to your own channel, Anuj. We are doing DPPs on redox reactions and titration, grade 11 topic, but useful for your JEE NEET preparation. So चलिए question 18 देखते हैं sequence में. In which of the following reaction, hydrogen is acting as an oxidizing agent. Hydrogen oxidizing agent की तरह से काम कर रहा है, यानी कि oxidize कर रहा है दूसरे को. Okay, options check कर लो आप सारे. With lithium to form LiH, with I2 to give Hi, with sulfur to give H2S. सल्फर से H2S में अगर आप लेके जाओगे तो 0 से -2 में जा रहे हो, तो एक रिड्यूसिंग एजेंट का काम कर रहा है. I2 to HI में 0 से -1 में जा रहे हो, फिर से रिड्यूसिंग एजेंट है. Li to form LiH, Li 0 है और LiH में क्या है, Li +1 हो रहा है, तो ये ऑक्सीडाइजिंग एजेंट है. ऑप्शन ए मार्क कर लो. सिंपल क्वेश्चंस है. 19th क्वेश्चन, द नंबर ऑफ मोल्स ऑफ मोर सॉल्ट रिक्वायर्ड पर मोल ऑफ डाइक्रोमेट आयन. मोर सॉल्ट का फॉर्मूला आता है FeSO4 अमोनियम होल NH4 होल्ड बाय SO4.6H2. आपसे डाइक्रोमेट की रिएक्शन करनी, तो Fe+2 को +3 में लेके जाओ. अमोनियम के साथ कुछ भी नहीं हो सकता, तो मेरे पास जो चेंज है वो यहीं पे मिलेगा +2 से +3 के लिए. डाइक्रोमेट कितना है, इसका एन फैक्टर 6 है, तो कितने यूनिट्स आप चेंज कर सकते हो? आंसर विल बी डी ऑप्शन, 6 यूनिट्स, बिकॉज Fe के लिए एन फैक्टर मेरे पास सिर्फ और सिर्फ 1 है. क्वेश्चन 20, फॉर रिड्यूसिंग 1 मोल ऑफ Fe+2 टू Fe, एन फैक्टर इज 2. चेंज आपको निकल जाएगा, एन फैक्टर 2 है, मोल्स 1 है, तो ग्राम इक्विवेलेंट कितने होंगे, 1 × 2. जितने ही ग्राम इक्विवेलेंट्स हैं उतनी ही फैराडे इलेक्ट्रिसिटी होती है. नोट कर लो कहीं पे, फैराडेज लॉ की समरी, ग्राम इक्विवेलेंट्स एंड फैराडेज विल मैच. 2 फैराडेज 2 ग्राम इक्विवेलेंट, आंसर विल बी 2. ऑप्शन नंबर ए. ओके, कमिंग टू द नेक्स्ट क्वेश्चन. क्वेश्चन नंबर 1, व्हिच हैज ऑक्सीडेशन नंबर ऑफ कार्बन इक्वल टू 0. किस केस में कार्बन की वैल्यू 0 है, राइट? आपके पास सारे ऑप्शंस गिवन है. चेक ऑप्शन डी. ऑप्शन डी में C6H12O6 है. O के लिए आप -2 मार्क करोगे, H के लिए आप +1 मार्क करोगे. A कितना आएगा इस केस में, 0 आ जाएगा. ठीक है, कर लेंगे सॉल्व. क्वेश्चन नंबर 2, इन अ रिएक्शन 2KMnO4 HCl गिविंग यू दिस, द रिडक्शन प्रोडक्ट इज. किस चीज का रिडक्शन हो रहा है, Mn+7 से +2 में जा रहा है, तो रिडक्शन प्रोडक्ट कौन सा हुआ बच्चों? ऑप्शन नंबर बी, MnCl2 आप मार्क कर लो. चेक क्वेश्चन नंबर 3, the oxidation number of phosphorus in Mg2P2O7, okay, pyrophosphate पायरोफॉस्फेट बनता है H4P2 वैसे ही स्ट्रक्चर हो रहा है. सो Mg2P2O7 में आपसे पूछा जा रहा है तो आप सॉल्व कर सकते हो इसको इजीली. आंसर आएगा क्वेश्चन नंबर 3 का ए. वैल्यूज लिखना आपको आता है, +5 इसकी वैल्यू आ जाएगी. Coming to the next question, 1 mole of chlorine combines with a certain weight of metal giving 111 grams of chloride. The atomic weight of metal is how much? 111 grams of chloride. 35.5 is Cl's atomic weight. 71 is Cl2. Okay, and 40 plus 40 units is their valency 2 है इसकी, right? तो आपके पास इसका एटॉमिक वेट मेटल का आपसे पूछा गया है कितना होगा, राइट? कैन यू मार्क द ऑप्शन? मेटल इज हैविंग एटॉमिक वेट ऑफ 80, राइट? यूज कर लोगे. एनी डिफिकल्टी इन दिस? मैथमेटिकल पार्ट इसका समझ में आ रहा है, मैथमेटिक्स समझ में आ रही है. इक्विवेलेंट ऑफ Cl2 लिखा आपने, इक्विवेलेंट ऑफ क्लोराइड लिखा और नीचे डिवाइड कर दिया. m आएगा 80 बिकॉज इट इज बाइवेलेंट. आई होप इट इज डूएबल क्वेश्चन. ओके, सी द नेक्स्ट क्वेश्चन. ऑक्सीडेशन स्टेट ऑफ क्रोमियम इन दिस कंपाउंड. ये कंपाउंड जो CrO5 है, इसमें O लिंकेज जो ये आपके साथ है, ये -1 है. दिस इज कॉल्ड बटरफ्लाई स्ट्रक्चर. एंड द अदर डबल बॉन्ड वाला ऑक्सीजन -2 होगा, क्रोमियम +6 में होगा. तो क्रोमियम का स्टेट +6 मार्क कर सकते हो. आई होप दिस क्वेश्चन इज क्लियर. कीप लाइकिंग, सब्सक्राइबिंग एंड शेयरिंग. थैंक यू फॉर वॉचिंग.
Yeah, full day. No, did she not go to school?
School से join कर लिया उन्होंने.
She would have gone.
Just go to that video and वो background है तो normal.
Okay.
अपने yes. Background and effects. None. Yes. Chinmay, Shyam, Niharika, please turn on your cameras.
So could you give me a few minutes? I'll turn it on in some time.
You're in school or what?
So I got really sick, so I came back home.
Okay, fine.
So-
Okay. Chinmay ji, how are you? Not audible. Mic problem. Shyam, how are you? All good?
Yes, sir. I'm fine. Just got a bit caught up today, so I had to come online.
Okay, no problem. Sorry. Yeah, chat you can remove.
I think Chinmay is type, but
He will, like, I think he will join Vikings sometime. Okay, chalo.
he's charging his headphones. Isn't he?
Okay. Okay, let's start. This was our last discussion. Please, like, I'm ignoring the yesterday's class, right? So that was this kind of extra class which came up for B1 batch. But this actual discussion, C7 and 16, if you go back, just check. Can you write ABCD for all of them? Anuj, फटाफट इसमें सारे cases में. And tell the numbers. So it will be 4 for this. A, B, C, D, E, F. How many? 6 for this. Check. This is complete, like there's no symmetry.
7.
So it will be 7.
Next one's also 6.
A, B, C, D. It will be 4. Okay. Because this one I'll not give any number. This is 4 degree. 4 degree को कोई भी number नहीं देना. Because 4 degree can't put any CL, right? Now come to this one. If I call this is A, this will be B. And these will be C. And this one I'll not give any number or any alphabet. Why? Because it is 4 degree. What is 4 degree? Carbon connected with 4 carbons, right? Can you answer why I'm not writing, I'm writing A here, but not A here and here? Why? Because after A there is a B, but after C there is no B. Is it clear? So they're not on the same footing. Is it clear? Correct. Next example. A, B, C, D, E, F. So your answer will come 6. Next example, A, B, C, D. No, this is 3. And the next one is A,
Oh, all of them.
B, C. That is 3. This one, nothing. So I'm marking where I'm not giving anything, I'm just marking it like that, okay? It will be 3. And the last one is A, B, C. Check the symmetry. ऐसे देखो. Can you observe? So they're all at the same location actually in the structure. So your answer will be 3. All right. Is it clear, Chinmay and Shyam? Any doubts you can ask on this one? No doubts? Okay, let's proceed further. So monochloro derivatives we learned in the last class, how to write ABCD and all. That's for monochloro derivative. Now let's say you write 1 chlorobutane and 2 chlorobutane. They will be considered as positional isomer, position isomer, because the position of chlorine group is different. But the parent name is butane in both the cases. So parent name same है butane है तो आप उसमें पोजीशन आइसोमर की बात कर सकते हैं, ठीक है। नेक्स्ट, if you write, let's say 1-chloro-2-methyl-propane and 1-chloro-butane, then the parent name is different, you call it chain isomer. I think this decision happened already, right? Any doubt in this part? So C5H12, total number of structures, check करिए, how many monochloro you are getting in C5H12. We have done this, check your last class. C5H12 total number is how much? C5H12 total number of monochloro. Total monochloros are how many? No, these are three structures.
Right.
Monochloro means when I write ABCD, then I add all those numbers.
Oh,
So this is C5H12.
right.
What will be that number? Calculate, please. Individual structure, what all alphabets you can write, and total how many structures will be out of there, right? Please do it. 8. आ रहा है सभी को? C6H14 कितने मिले? C6H14 check. This write ABCD for this. Then count for each case, add everything, and then get the numbers. 15. Answer is 17. Check once again. C6H14 answer is 17.
Yeah, no problem.
Check structure by structure. First one ABC CBA, so 3. Next one ABCD, so 5. Next one ABBCCD, so 4. Next one, these three are A, then B and C. The middle one I will not give any number because of 4 degree. This one, just 2. Corner one's B and the middle one A. If you add all of them, it should come 3 plus 5, 8 plus 4, 12, 3, 15 plus 2, 17. एक बार चेक करना कौन सा आपने मिस किया है, कहाँ पे लोगों Shyam, did you get 17 for this question?
Yes, sir.
Chinmay, did you get 17 for this question? Okay, great. And Niharika, did you get 17 for this question?
Yes, sir.
Okay, all right. You're having cold, Niharika, right? I think yesterday also you're having cold.
Yes, sir, but it got much worse today.
Okay. Take rest, okay?
Yes, sir.
Yeah. Now, next discussion was C7H16. Total was how much? Abhi kiya aapne 2 minute pehle. Just add all the numbers. It came 39, I think, right? Just check. We have done few minutes back. 10, 17, 21, 24, 30, 33, 36, 39. Check कर लो. ठीक है, ये information समझ में आती है? So what are we drawing? What are these 39 structures representing? They are all called structural isomers. What is the meaning of structural isomer? Where the structure is different. So we can draw different structures. Under structural isomer, which one is chain isomer? Where the chain is different. For example, let's say you take any of these 4. Or let's say this structure versus this structure. This is chain isomer. If I want to draw monochloro derivatives and then check chain structure, chain isomers. So you can say if I put here, here, or here in these cases, they are all position isomers in the given structure. But if you compare these two, then chain isomer. कर लो, कोई problem यहाँ तक? Good. Now move further. Write down the heading. Functional isomers. Chain and position isomers are clear to everyone? Any problem with that? Now you can mention heading functional isomer. What do we mean by functional isomer? Functional isomer is basically when functional groups are different and the formula is same. Example के तौर पे आप ले लीजिए C2H6O. Just take this example. Okay, write down C2H6O. So C2H6O can be C2H5OH and this can be CH3OCH3. These are two probable options. C2H6O can be CH3O, CH3 or C2H5OH, right? OH group is called alcohol. इसके last में suffix आता है also. See, we have informally started IUPAC also because basic names and all we are understanding now. All is a word which is to be used. So this compound is called ethanol, right? Ethanol. Similarly, methanol is CH3OH. Propanol is C3H7OH and all those. Okay, can you write structure of butanol? How will butanol look like? Aaron?
C4H9.
Any problem with this part? What is this other structure?
Ethanol.
This is called ether, right? What is ether? Ether will have oxygen, and both side valencies are available, right? Remember, it can't be hydrogen. As soon as this becomes hydrogen, it is no more ether, it is called alcohol. So how will you recognize ether versus alcohol? Ether cannot have around oxygen hydrogen. It will have some alkyl group or some group, right? So what is this compound? Is it ether? Please answer. Is this compound ether? No. It is ether. This is a pH group, oxygen and CH3. It's an ether. Okay. Is this compound ether? Yes, it is also ether. Oxygen, one side one group, one side some other group, right? They are all ethers. So not necessarily CH3 होना चाहिए, कुछ भी हो सकता है group, right? But not hydrogen. Is this compound ether? No. This is not ether because hydrogen is here. कर लोगे? So if you have oxygen, both sides you have some group which are not hydrogen, then you can call it ether. Simple. So can I say any alcohol and corresponding ether can be known as functional isomer because they both are having no unsaturations, they both are having oxygens, they both are having other things, carbon, hydrogen, right? So structures can be drawn. Just try one more question right now. C3H8O. C3H8O. Try to draw possible alcohols and possible ethers of it. C3H8O क्या है? Possible alcohol क्या होंगे और possible ethers क्या होंगे? Try करें. Done. C3H7. Okay. Can we draw other alcohols in this? Any other alcohol apart from this? What is the structure of this? Like 3 carbons in a chain? Yes. Don't worry about hydrogen. Don't worry about hydrogen. Just worry about carbon chain and OH. This is one option. Good. Yeah. Draw the second structure, not the same structure. Okay. Keep OH in the second. Please draw all possible alcohols and all possible ethers for this compound. Okay. So now if you draw first compound. Yes. Yeah, I come. Any doubts? So see, number of unsaturations will be 4 minus 4, that will be 0. Okay. Can we check 4 minus 4 is 0 in this case? 3 plus 1 minus 8 minus 0 by 2. Formula याद है आपको? So 4 minus 4 is 0 unsaturation. अभी 0 unsaturation आपके पास आ रही है. That means there is no double bond, there is no triple bond, there is no ring. So you have to just draw single bonds and OH. So आपने draw किया 3 carbon straight and 1 OH. Can you do that? This compound in general name, right now, general name is called normal propanol, or we can say propanol, right? But IUPAC name is propan-1-ol. This one indicate that if I do numbering, OH is attached on position number 1. Okay. So you can call it normal propanol, or you can say propan-1-ol. When you say propan, shall I say propan-1-ol? Can I write E here also? No. Whenever you write propan, that's alkane. When I remove this E and then write OL, that makes alcohol. Right? So E cannot come. It won't become eol, right? It become propanol, right? So E आपको remove करके then now get now. What is the name of this compound? If second position is involved, we can say 2-propanol or propan-2-ol. कर लोगे? A position OH, propan-1-ol. B position OH, propan-2-ol. Can you draw any other answer? C position है ही नहीं. ये A है और ये B. There are two positions only. How about ethers? So ethers will be like this: CH3O, CH2, CH3. Can you draw any other ether? Somebody can say, "Sir, मैं ऐसे बना दूंगा." But I same ही चीज होगी. There's no difference. Just merely tilting it to 90 degree won't make it some new compound. It is the same compound, right? Somebody make it like this. It's the same compound. Somebody can make it like this. It's the same compound. Understand? They are all same. There's no difference you are creating out of it. Now, how to write name of this? First of all, this is ether. Name of ether is, now I am giving you informally introduction for IUPAC already. So ether's formula is alkoxy-alkane. Note down. Ethers are alkoxy-alkane. What is alkoxy? Alkoxy is the shorter group or smaller group, and alkane is the longer or main chain. Okay. अब ध्यान से सुनना मेरी बात. You have this compound. Can you figure out around oxygen there are two groups? One side is C, one side is CC. Which is the longer one? Alkoxy is shorter, and this is longer. So which is shorter? Which is longer? If you draw any ether out of it, what kind of ether you have drawn? You have drawn this. Which is the long group? CH2, CH3 is a long group. Can I say this is the long group? So the parent name will have alkane's name as what? Ethane. Check please. Two carbons are called ethane. Are you understanding this point? So first you figure out what is a long chain and give the name ethane. And then the other part is alkoxy. Now what is this group? Can I say it is methyl group? So what shall I write? I cannot say methyloxy. It is called methoxy. Okay. So the name will become methoxyethane. Simple. Please note down. Methoxyethane is the compound. Everyone, please try to draw ethoxymethane. Can you draw ethoxymethane? Can we draw ethoxymethane? Can there exist such compound called ethoxymethane? Why it is not existing? Yes, because shorter name I am giving as a name. That's a wrong name. Is it clear? So try to understand. If you're given, let's say, 4 names, and one question is which one is not possible, you should understand what is not possible, right? Ethoxymethane has no sense because methane, 1 carbon, ethoxy, 2 carbons. How can you do that? It has to be called methoxyethane. Can you draw ethoxypropane? कैसा दिखेगा ethoxypropane? So आप propane के लिए 3 carbon बनाइए, ethoxy के लिए. आगे check कर. Niharika, is it clear? This compound is called ethoxy 1,2,3 propane. कर लेंगे? Any difficulty? What about this compound? What should I call this? Let me try to do this. क्या बोलना चाहिए इसको? Arab. Where is the main chain? This is the main chain. Long chain is this.
Methoxypropane.
Okay. And what is the name of this compound? Arab. That is also methoxypropane.
Yeah.
How will you differentiate them? This is position 1 methoxy and this is position 2 methoxy. So please write down
Methoxy-2 propane.
2 methoxypropane. 2 methoxypropane. That means second position methoxy is involved. And this is a propane. But this one is 1 methoxypropane. Yes. So if OC is hanging here in the middle at this place, it's position number 2. So it's a 2 methoxy. How will you identify 2 methoxypropane? Is it clear? Here it is position number 1, so I'll call it 1 methoxypropane. Please write down both the names. And online people, is it clear? Raise your hand if it is fine. Sham, Chinmay, and Niharika. Is it clear? Great. So can we do such things? 2 methoxypropane and 1 methoxypropane, you can draw these structures without much trouble.
But how do you use comma when you use something?
In which case, as in?
Like, is it 2 comma?
No, 2-methoxypropane. Second
When do you put
position
comma?
methoxypropane. When you have dimethanol, we come. What are the names of this? Next, write down C4H10O. C4H10O. Try to draw possible alcohols and possible ethers out of it. Correct. Try correct. C4H10O, possible alcohols and possible ethers. जितने भी बना सकते हो बनाओ. Possible alcohols and possible ethers. Possible alcohols and possible ethers. Number of unsaturations will be 4 plus 1 minus 4 plus 1 minus 10 minus 0 by 2. That is 5 minus 5, that is 0. 5 unsaturations को कैसे take care करो? Sorry, 0 unsaturation को कैसे take care करो? We can have 4 carbons in a straight chain. Now write ABCD on that and draw a structure. 3 carbon in a straight with 1 branch. Write ABCD on that. Then write merge. Okay. Then for ether part, 1 carbon one side, oxygen 3 carbon other side. Can be a straight chain. That straight chain can be branch chain also. The next will be 2 carbon this side, 2 carbon other side. सारे structure बना दीजिए. Good. First सही है, second ठीक है, ये भी ठीक है. But now I'm just trying to figure out. This is 4 members in a straight, right? Can there be 3 members straight, 1 carbon branch? That will also be C4H10. This question. No. This is not same as this.
So, how many branch chains will there be?
You can give 1 carbon, yes. Now you can put OH here, or you can put OH on terminal. Because these 3 are one type, and this one is another type. So draw structures.
Can I hang so 3 carbons OH. This carbon can I put below here.
This is correct. Good. This is correct. This is correct. This is correct. Draw one more. No, you draw all 1, 2, 3 carbons, and then put OH on terminal ones. Because if this is A, these 3 are B.
Right.
So you have put already on A position. Now you can put of any of the B positions, right? Correct. Solve kariye, solve kariye. So to draw any structure, you need to understand how do we write the skeleton. Once you can draw that skeleton, you can get the answers. Hello, sir. बस एक क्लास में बताइए. एल्कोहल्स कितने मिल रहे हैं? 4 एल्कोहल्स मिल रहे हैं सभी को. Good. 1, 3, 2, 2.
These are the same. These 4. This is same as this.
अच्छा ठीक है, ये 4 है ना. So 1, 3, 2, 2. 3 को आपने बाइफरकेट कर दिया. ये क्या किया? वो कॉर्नर में कहाँ चला गया?
I can't go in the corner.
No, that is already drawn in. These are the same structures.
Okay.
तो OH हो गया ना grays.
So 7.
This is the next.
This is same as this. Just give me a minute. See. When you draw, first you draw skeleton.
This needs to put here. This
Yeah,
Y.
so this is A, this is B, B, B. Now, first you put on A, then you put on B, OH. Understand? Put on A carbon OH. That will be different from putting OH on B carbon. That's why we're learning that ABC.
So it's only 7.
So ether में आपके पास 2 2 1 3, हाँ correct. 1 3 में 2 possibilities and 2 2 में 8. Check all these structures, everyone. So I have drawn butane 1-ol. First confirm this that you get butane 1-ol. RS आपका butane 1-ol. Then another structure is butane 2-ol. Niharika, are you getting this? Butane 1-ol, butane 2-ol. 4 carbon straight, first position OH, second position OH. Next example, we are getting 2-methyl propane 1-ol. Second position पे methyl and OH here. Then one is 2-methyl propane 2-ol. These are 4 alcohols that you can draw. Any problem with this? Now, butane 1-ol and butane 2-ol are positional isomers. Butane 1-ol and 2-methyl propane 1-ol are chain isomers. Butane 2-ol and butane 2-methyl propane 2-ol is also chain isomer, right? And these two are also what kind of isomer? 2-methyl propane 1-ol and 2-methyl propane 2-ol are positional isomers. Clear? ये तो हो गया आपके चारों. Complete हो गया इतना काम. ये साइड में रख दो. Now coming to the next part about ethers. So we can draw 3 ethers. One is 1-methoxypropane. Check कर लीजिए. 1-methoxypropane बना सकते हैं हम. Chairman. Correct. Other is 2-methoxypropane. Second position पे OC लगा दो. यहाँ से hang कर दो. And the last is 1-ethoxyethane. 2 carbon this side, 2 carbon that side. Correct. Total 4 carbons are there, no? We can have 2 carbons, and don't worry about hydrogen because we're worrying about hydrogen. That's why we're missing structures. Worry about skeleton. Skeleton समझ में आ गया एक बार तो आप कर लोगे. कैसे उसका basic structure है वो दिख गया एक बार आपको तो question solve हो जाएंगे सारे. फिर कहीं कोई दिक्कत नहीं. Is it clear? Shyam, Chinmay, Niharika, if it is clear, please raise your hand. It is fine. All right. चलिए थोड़ा आगे बढ़ते हैं. Try to write another word called metamers. लिखिए metamers. Jumbling number of carbons around functional group with minimum 2 bonds. I repeat, or minimum 2 valencies. Jumbling number of carbons around functional group with minimum 2 valencies. So let's say you have oxygen like this, or sulfur like this, or C double bond O like this, and you're playing around with number of carbons on each side. Okay?
Can you show that statement?
Yeah. So jumbling of number of carbons around functional group with minimum 2 bonds. We can add 2 valency, right? Or 2 bonds is also fine. Minimum 2. 3 भी हो तो चलेगा. Example के तौर पे देखिए. Look at this compound. Can they be called metamers? Which bond I'm talking about? I'm talking about this bond. Oxygen, oxygen.
But did not understand what a variable.
I'm just trying to explain. Just see this bond, O, right?
Mhm.
Total 4 carbons are there. How can you arrange 4 carbons around this? Exactly. So these are called pair of metamers. So you are playing around with the number of carbons. 1, 3, 1 this side, 3 this side, or 2 this side, 2 this side.
That's what we did, right?
So these are structurally different structures which are called metamers, right? Or third type of isomers.
These becomes a metaphors.
Yes, these are metamers. Correct. Now we can also understand that this metamer is a chain isomer also, because see, there's a 3-member chain, and on this it was methoxy, and there's a 2-member chain, on this it was ethoxy, right? Somebody can call it chain isomer also. Correct, that is also true. But metamer is more specific name. So when chain isomers, it is a chain isomer also in a way. But I will prefer calling it metamer because it's having that property which is making it unique about isomers, right? So metamers is the more unique property. Okay, we can call it chain isomer also. Now look at this: 2 carbons around sulfur and 3 carbons and 1 carbon around sulfur. When sulfur comes in place of oxygen, it is called thioether, introducing one more functional group to you. Thio means sulfur. कभी भी thio word आएगा, हाँ, that is sulfur. thioether. Ether is oxygen. Thio means O replaced by sulfur. Okay. This is cyanide. Okay. If I put SN, thiocyanide. It is cyanate or isocyanate. If I put CS, it becomes isothiocyanate. Understand? So thio word is basically representing sulfur. Just this much is enough at this moment. Sulfur दिख जाए, thio word आपको आएगा, that's okay. Don't worry about all the names right away. So gradually we will try to learn each and every name, but it will take time. Don't worry. Don't rush towards it. Let it come to yourself, right? Come to you. Can you look at this compound? NH. What is NH called? Which functional group is this? Anybody? Nitrogen, hydrogen.
Ammonia.
These are ammonia derivatives, right? So पहले सबसे आप लिखो. यहाँ पे सीखो एक term. This is ammonia. Right? This is ammonia. Ammonia has how many hydrogens? 3. If you replace one of the hydrogens with some alkyl group, it is called primary amine. If we replace 2,
Secondary and tertiary.
yeah, it will call secondary amine. If we replace 3, it is tertiary amine. And if you put one more, like you replace NH4 plus, for instance, right? NH4 plus सुना आपने? What is this called? If I put NH4 plus. So this is called ammonium. Okay, ammonium ion. So if you replace all 4, let's say with some R prime, and we put a plus charge, it is called quaternary ammonium salt. Quaternary ammonium salt. Okay. I repeat once again my statement. Hear me out carefully. This is important discussion. Ammonia is NH3. RNH2 means replacing one of the hydrogen, putting any group like CS3, C2H5, making primary amine. Do it 2 times, secondary amine. Do it 3 times, tertiary amine. Do it 4 times, quaternary amine. Okay. Quaternary amine. Is it clear? Or quaternary ammonium salt. Yeah. Now go to the statement of metamers. In metamers, we have written one statement that the group should have minimum how many valency? Sham. Minimum how many connections? 2. Okay. So think about NH2. NH2 has just one connection, RNH. Can it give metamer? Answer is no. It can't give metamer. How about NH? NHRR. Can it give metamer? Yes. Because NH has 2 connections. One side R, other side R. Now you can just play around, right? For example, NH is given. I put 2 carbon here, 2 carbon here, one option. I can put 1 carbon here, 3 carbon here, other option, right? So NH can give. Can N also give? Yes, because minimum is 2. If you have 3, that's okay, fine. So how will you play around? Let's say I'll give one example. If you have, let's say, nitrogen on this 1 carbon, 2 carbon, 3 carbon. And the other situation is 2 carbon, 2 carbon, 2 carbon. Just compare. Will they have same structural formula? 3 plus 2 plus 1 is 6. I'm putting 6 carbon in the distribution of 2, 2, 2 each. Other case 1, 2, 3 each. Don't you see that there is a metamer possibility? Okay. So that jumbling, that you're playing around number of carbons around a given group which has multiple valencies is known as metamer. Clear? Arav?
Yes.
Is it fine? Any difficulty in this? Clear? Okay. So note down these examples. This is clear. The last one is also clear. Okay. Fine. Can you observe? These are metamers. Are they metamers first of all? Let's look at this. 1, 4, 2, 3. They're metamers. How about these two? Can I call it metamer? 1, 4, 1, 4. They are 1, 4, 1, 4. But the problem is that 4 is arranged in a different way. Are they called metamers? Answer is no. Now it is position isomer. Because you're not playing with the number of carbons. You're keeping the number of carbon 1, 4 only.
Chain.
It's position. Why position? Because your chain is same in both the cases. 4 members. Yes.
Branching it out is
Fine. Just write down the name for each. You will understand. Write down name for each. First one is. देखो अगर चेन आइसोमर होगा तो आपका चेन डिफरेंट होना चाहिए. क्या आपका चेन डिफरेंट है इस केस में? जस्ट चेक. Carbon, oxygen, 4 carbons. What is the longest chain? 4 carbons. What is the longest chain there? 4 carbons.
Yeah, but this carbon chain of 4 carbons isn't continuous, like.
It's continuous, no? These are 4 carbons. Just draw. This is the same example that you've done a few minutes back. 3 carbons, terminal position OC. 3 carbons, middle position OC. It's the same example, no? अरे ये क्वेश्चन थोड़ी देर पहले आपने क्वेश्चन किया है कि नहीं, जहाँ पे मैंने ये बताया ये राइट. Look at this question you've done 3 carbon के साथ तो किया है ना. Look at this question. Now what is happening? ये इतना ही तो फर्क है. So how it can be chain isomer? This is the chain. This is the main chain. This is the main chain.
So
4 members.
it's different position.
1 methoxy, 2 methoxy. Write the IPAC name of each in minus 3. How do you write IPAC name of the first compound?
Methoxy.
Oh, okay, I got it.
Methoxybutane. Which position methoxy is connected?
First
So what is the name? Write down the name.
one.
1 methoxybutane. Write the name of second one. Sham, is it clear? Chirma, is it clear? Niharika, is it clear? Second one is 2 methoxy. So if both are butane, how can they be chain isomer? To make chain isomer, you need different chains. That's what the first line, right? If parent name is same, then it is position, not chain. Is it clear now? Can I call it metamers? No, because metamers should be different number of carbons around it. That's not happening around, right? So metamer भी अपनी बोल पाओगे.
So basically, chain isomers and metamers are the same thing.
No. Metamers, you can't get metamers in all the cases. You can get metamers only in those cases or only in those chain isomers where we have 2 valency minimum and you're playing around, right? Like oxygen with 2 branches, like one side and another side. Sulfur with 2 ends open, right? But chain isomer I can get anywhere. I don't require 2 members or 3 members or any such rule. Is it clear, Sham?
So all metamers are chain isomers, but not all chain isomers are metamers.
Can say.
Right?
Can say. Yes. Next point. So functional isomers category, write down the first one, alcohol and ether. Alcohol and ether can be one scenario. Already we discussed about it, right? आपने alcohol draw किया, आपने ether draw किया. Second category could be thioalcohols and thioethers. Thioalcohols and what is thioalcohol? SH. OH की जगह SH आ गया तो thioalcohol हो गया. Thiol बोलते हैं इसको. And thioether is same as ether, right? Only difference is O will become S. Correct? Is that fine? What else is there? Third cases, which we have not discussed so far, right now, acid and esters. What is an acid? इनके formula भी लिख लेना please. What is an acid? What is the formula of acid? So acid is acetic acid आपको पता है, right? CH3COH. So this is acid. C double bond O, single bond O, H. It's called acid. Okay. What's an ester? Ester is also having C double bond O, but why do we call it ester? Why not acid? The problem is this O should not be connected with hydrogen. If it is connected with hydrogen, you would call it acid. Same, ether, when OH is there, you call it alcohol. When H is not there, you call it ether. Same is here. If C double bond O, single bond O is given, if H is here, you'll call it acid. If H is not there, some other group is there, you call it ester. Fine. Niharika, is that fine? Sham. So now, let's understand how do we write names for these. So let's say we write C double bond O, H, H, and H, C double bond O, OCH3, and C double bond O, CH3, H, and OC double bond O, H, H. अब खोना नहीं आपको खो गए lost.
So
Right.
first and last one is the same.
यही ऑब्जर्व करना है इसीलिए दिया मैंने. चलो ऑब्जर्व कर लो कौन से सेम है कौन से अलग है कौन से क्या है.
No, it's them reverse.
चलिए अभी छोटा सा काम करते हैं. First thing, you tell me which one is acid, which one is ester. Let's start. So what you have to observe? What you have to observe? बताइए.
Which one is acid?
Acid,
Acid CO, ester is RCO.
Good. So COH कहाँ पे मिल रहा है अपने को? यहाँ पे मिल रहा है. Acid है.
Third one,
ये वाला भी acid है.
fourth one.
ये वाला C double bond OH देखो मिल रहा है. That's an acid. This one is not an
That's it.
acid. Others are not acid. Is it clear?
Yeah.
How do we write name of acid? That's very simple. So what we do, we count the carbon also in the chain. This is the chain. Let's start from here. So I'll put 1. Okay. 1 carbon is called methane and COH is known as oic acid. So the name of compound will be, I'll cut E and just connect them. So the name of compound is methanoic acid. If somebody say methanoic acid is this compound. Its general name is formic acid. Again, these things will come later. Don't worry too much about it. But methanoic acid we can mention right now. Arav, can you draw ethanoic acid? Propanoic acid, everybody draw. Ethanoic acid, propanoic acid, butanoic acid.
So that's ethanoic acid, right?
Keep drawing, keep drawing. Ethanoic acid is also called acetic acid, CH3COH, right? Propanoic acid is CH3CH2COH. एक और कार्बन ऐड हो जाएगा. तो पहले एसिड कंफर्म करते जाओ. सारे एसिड के स्ट्रक्चर्स आपको आने चाहिए. HCOH is formic acid or methanoic acid. CH3COH is acetic acid or ethanoic acid. CH3CH2COH is propanoic acid or propanoic acid. Okay. And then butanoic acid is C3SN. Good. Cutting, simple सी बात है. Now, acid is clear. Any confusion in that? Now coming to other side of story. Other side is ester. So this is an acid. ये हो गया और ये भी हो गया. Now coming to this part. How do you decide these are not acids? So you can check. This is OH. This is OCH3. So this is not an acid, right? How do you write name for it? So anyone?
Methyl.
So what's the ester prefix suffix?
यही तो मेरा question है.
Oh,
Very good. It is called alkyl alkanoids. Okay. Alkyl alkanoid. So I repeat, the name of ether is alkyl alkanoid. Alkanoid is the main chain, and alkyl is the group which is hanging on oxygen. I repeat, listen to this very carefully. What is hanging on oxygen? What is connected with oxygen? You call it alkyl. Again, what is connected on oxygen is called alkyl. And what's your main chain? Your main chain starts with this carbon. Now this is slightly tricky. Can you observe? Your main chain is this, starting from carbon. Okay. And then you write number. For example, if you have to write name for this compound, I'll say one carbon here and one carbon here. So what is this? Methyl. And one carbon's methanoid. What do we? Methyl methanoid is HC double bond O single bond CH3. Niharika, are you understanding this part? Chinmay and Shyam, is it clear? So this compound is methyl. And this carbon one, so we'll call it methanoid. What is this compound? RF.
So which one?
This one.
Same thing with higher.
It is same compound actually. Just written other way around. Just observe these things. Okay. वो CH3 O C double bond OH लिख दिया तो उससे acid नहीं बन गया. It's the same compound. Can you observe these small things? Next, what is the name of this compound? Shyam. बताइए.
But it's methyl ethanoate. Yeah.
Very good. Methyl ethanoid. Two carbons are set, so methyl ethanoid. Simple. कर लोगे. बहुत simple सा काम है, इतना tough है नहीं. So see, again, I'll go into detail of esters, IUPAC, कैसे भी group लग जाए तो क्या करोगे. But that's a secondary discussion. We are not doing IUPAC right now. We are trying to understand some basics of functional isomers. We are just restricting ourselves to that discussion. Is that fine? Okay. So you can draw this compound also. Any problem with this? Any issue with this? Okay, so all these structures are clear. Now coming to next part. So acid you understand, and alkyl alkanoid you understand, propanoic acid and all those things you understand, right? Okay. Now, can I call these two structures as metamers? Please draw both of them and tell me whether can I call them metamers or not. So metamer, first condition is they should be both same functional group. Are they same functional group?
Yeah.
They both are esters. How do you know both
They
are
are
esters? Because this is C double bond O. O is not having hydrogen. They should have same structural formula. Formula is C3H6O2 for both of them. That means we can talk about isomerism. To get metamers, we should have C double bond O hanging. One side 2 carbon, one side 0 carbon. Other side 1 carbon, 1 carbon. I think we are playing with 0, 2 and 1, 1. Can I call it metamers?
Yeah.
Yes or no?
Yeah.
Answer is yes. They are metamers because, yeah, both the formula is same and both side groups are different. So they are metamers, no doubt. Esters can also show metamers like this, no doubt. So now you know that more groups. What are groups? Oxygen, ethers can show. Sulfur, thioethers can show. Then we discussed NH can show. NH one side something, one side other thing, right? That can also show metamers. Sanjana, is it clear?
So, but the names are different, that doesn't matter.
Names as in?
Like the first one would be ethyl methanoid, the second one would be,
Methyl ethanoid.
Yeah.
Correct. That's what.
so ethyl methanoid
And
and
methyl.
And methyl ethanoid are metamers. They are actually chain isomers also. They should be chain isomers.
If they're
But I'm calling it metamer because that's a better way to say it, right? So chain isomers के अंदर specific बात हो गई ना. See, it's like
apples are fruits, but not all fruits are apples.
Wait, so
can say that, yes.
all chain isomers are metamers.
All chain isomers, no, all metamers are chain isomers. Metamers are inside, the specific part is metamers, right? So metamers is like apple, and
All
chain
fruits
isomer is
are-
fruit. So you're saying fruit, that's chain isomer. In fruit, कौन सा fruit है? वो बता दिया तो अच्छा है ना? वरना आप apple को भी fruit बोलोगे, banana को भी fruit बोलोगे, सबको fruit बोलोगे. So we are just telling that metamers means I'm being specific about it. Is it clear? Clear? Any doubts? So these two are methyl ethanoid and methyl methanoid are also to be considered as metamers. Okay. But if you take this ester and this acid, what are these two? Functional isomers. Abhi discussed here. Functional group is different. This acid and this ester, functional isomer. Understand? This acid and this ester, no isomer. Formula is not same.
Yeah.
थोड़ा सा ध्यान रखना यहाँ से भावनाओं में नहीं बह जाना कुछ भी लिख दिया right चलिए next point so butanoic acid can you draw C4H8O2 now try to draw butanoic acid formula is C4H8O2 try to show what all acids and esters can be formed their IUPAC name their combination as metamers their combinations as functional isomers please do everything so try to draw all possible acids try to draw all possible esters. Try to show connection between acids and esters in such a way that which one is functional isomer, which one is what do you call positional isomer, which one is chain isomer, which one is metamers. Whatever you can show, try to do this. Correct. C4H8O2 unsaturation कितने में क्या रहा?
Saturation 4+1 minus 8/2. 1.
And that is C double bond O. That represents C double bond O. So now draw these structures. And there are two oxidations. So one thing is very clear that I can have a C double bond or C double bond C. But when I'm telling you please draw acids and esters, so this much is fixed. So this much is fixed. That means C4H8O2, O2 is fixed. One carbon is fixed. You are remaining with 3 carbons. Now just place around 3 carbons. What are your options? 3 carbons here, H here, 2 carbons here, C here, 1 carbon here, 2 carbons here, 1 H here, 3 C's here, 3 carbons here as branch, and then right. Just please draw all these structures. Correct.
There are metamers for carboxylic acid.
No, because carboxylic acid is having fixed hydrogen, and metamers requires jumbling around anything which has 2 valence, right? So that is not possible in this. ऐसा group आपको ढूंढना होगा.
Butanoic acid won't have methanol.
Yeah, ऐसा group ढूंढना होगा. Group which has 1 arm and another arm at least.
Esters.
If it has 3, even fine. It's okay.
Esters will have methanol.
Esters can have methyls, yes. आगे समझ में बहुत बेसिक सी चीजें बट इसको अगर अच्छे से करोगे तो कॉन्सेप्टली साउंड हो जाओगे हाँ समझ में आ गई चीजें क्लियर हो गया अदरवाइज कंफ्यूज रहते हैं बच्चे अभी आप जो मिस्टेक करो वो देखो आपने यहाँ पे कितने बॉन्ड बना दिए 1 2 3 4 5 so the problem is you go in system C double bond O4 this is an acid okay do it this way how many carbons are there 4 carbon में से एक carbon यहाँ पे consume होगा तो कितने बचे 3 carbons 3 carbons can be like this 3 carbon can be like this keep it fixed okay no 1 2 3 4 I'm writing 1 carbon.
Oh.
1 carbon is fixed here. 1 carbon is fixed here, right? So 3 ऐसे हो सकता है या फिर branch हो सकती है. Any other option?
No.
3 straight बना दिया आपने. And then this. Any other option? No. So these are 2 acids. What is the name of this acid? 1 2 3 4 butanoic acid. What is the name of this acid? 1 2 3 2 methyl propanoic acid. हो गया ये done. अब आओ दूसरी तरफ second side you have the same thing C double bond O so you just frame C double bond O single bond O, and then try to put carbons. Total, how many we have? 4. So it can be 1, 3, it can be 2, 2, it can be 3, 1.
Yeah.
Remember, 1, 3 and 3, 1 are not same because this side 3 oxygens connected. And there can be one more thing. When the 3 are there, the 3 can be branches, 3 can be straight.
Yeah.
Okay. 1, 2, 3 or 1, 2, 3.
So total 5.
Here also, this 3 can be 1, 2, 3 or 3 can be 1, 2, 3. अब आप सारे cases समझ गए? अब draw करो. And don't worry about hydrogen, just draw our schedule. Okay. Is it clear? So let me repeat once again. I'll just show this part. So C4H8O2, number of unsaturations आप solve करोगे, it will come out to be how much? Number of unsaturation 4 plus 1 minus 8 minus 0 by 2 will come out to be 1. One unsaturation is assigned to C double bond O and oxygen. So one oxygen is gone, one more oxygen is gone, and one unsaturation is gone. Your compound has C4H8O2. That means one carbon is gone, so 3 carbons are remaining. If I put hydrogen here, 3 carbons can be straight, 3 carbons can be branches. These are 2 probable acids. If I put this structure, now we have total 3 carbons, 1, 2, okay? अच्छा 4 ही carbons है शायद total, तो 1 3 बन पाएगा, हाँ ठीक है. No, this will not be possible because total are 4 members, no? So 1 यहाँ पे हो ही गया ना, तो आपके पास 1 2 और 2 1 ही निकलेगा. Next case में आएंगे और सब cases because 4 ही है ना, 5 नहीं है आपके पास.
So just
That is for the 5 case. Yeah, I think you have not found it. 2 carbons, good. Write the names. 3 वाले में 3 1 4. 3 वाले में एक branch बन जाएगी.
Yeah, you have 3 S.
Yeah. So, but aren't this and this the same thing?
As per the connection, no. If you connect with this carbon or this carbon, they are different.
That symmetry will be different, so O is there.
OC double bond OH.
So like that. Okay.
Can we complete this? So how many acids we are drawing, Shyam? From this structure, how many acids we are drawing?
Sir, so now we've drawn 4 or 3
Acids. 2 acids.
or 2.
One acid is this. See? One is this. Other is these are acids, right?
Sir, but you can also put the acid group in the center, like a branch.
After the H, you can't put C.
Okay. Basically, what you're drawing is the repeat structure. Just look at this, what you've drawn. Can you tell me how you've drawn?
Like 3 carbons, and then in the middle put
COH, right? This is same as this. Check this.
okay.
3 carbon and then COH. It's the same thing you're drawing. Understand? That's the repeat. So only 2 acids we can draw. What are the name of acids? Butanoic acid and 2-methyl propanoic acid. यहाँ तक हो गया. Butanoic acid and 2-methyl propanoic acid. Right? On the other side, we can fix C double bond O. We can keep one side hydrogen first. पहले ऐसे करो, sequence में चलो. Keep hydrogen one side, not oxygen side. Otherwise, acid बन जाएगा. Keep on other side, the left side. Okay, CO side. And then play around with number of carbons. So 3 carbon in a straight, 3 carbon in a branch. Okay, sunrise appear. Look at the first one. What is the name of the first compound? Propyl methanoid. Next one. So next one name is slightly difficult. You can say this is ethyl, but on first, so we have branches now. Now this numbering and all you have not done yet, so I don't expect that you can understand these names, but still I'll try to just mention. After a functional group or a group is drawn and we want to do sub-branching, we use prime. If you do further branching, we use double prime. So in this case, if you observe, I have an ethyl group. Had it been ethyl, I would have called ethyl methanoid. But in this structure, this ethyl is hanging one CH3 on it, right? This C. So what is the name? 1 prime, 2 prime, and 1 prime पे methyl hang कर रहा है. So what do you call it?
1 prime methyl.
1 prime methyl.
Ethanol.
No, 1 prime methyl ethyl methanoid.
Okay.
See, methanoid I'm not disturbing.
I got it.
Okay, let's remove it.
Wait, 1 prime?
Listen. I'll explain.
Methyl.
What is the name of this compound? पहले इसका नाम बताओ. Ethyl methanoate. Is it not correct?
So one carbon is missing.
That's what. One H is missing.
Then
One H is missing.
One CH3 is missing.
I removed deliberately.
Oh, okay.
In this structure, what is the name? Ethyl methanoate. Is it clear, everyone? Raise your hand if it's fine. This compound is ethyl methanoate. Okay. Now, if you hang one CH3 here, basically on 1' position, one methyl is hanging. So I'll call it 1' methyl. I'll put a bracket, right? Ethyl, because the whole thing is ethyl, right? And then I'll say methanoid. Easy.
No.
Okay. If it is fine, you find it difficult, let's go with the rules of IUPAC once we'll start. Okay, don't worry. At least you can draw the structure. Forget about the name of IUPAC name and all. Structure of bana pa rahe ho, more than enough. No problem at this moment because I'm not discussing IUPAC. It's just a side effect, right? So we'll be doing it detailed. Don't worry. Next example. 1 carbon this side, 2 carbon this side. What is the name of this compound? ये तो पता है. Ethyl ethanoate. ठीक है. और एक और क्या बनेगा? 2 carbon this side, 1 carbon this side. Methyl propanoate. कितने वाले structures बना लिए हैं? Raise your hand. Now in this, can you mark these two as position isomer? Please check. These two as position isomer. Yes, because the name of this compound is propyl methanoate. The name of this compound is 2-ethyl methanoate. Okay, both are methanoate only, right? Because my ester's name is fixed. It's not going to change. Look at these two. What are these two? Ethyl ethanoate and methyl propanoate. What are these two?
Metam.
Pakka?
yes.
Yeah.
They can be called metamers. Can they be called chain isomer? But chain isomer is calling them fruit. Metamer calling them apple. So that way it comes. Is it okay? What are these two? Functional isomer. These two, these two, these two, any of these two. Functional isomer. Acid ester लेके आओगे functional isomer बनोगे. What are these two? Any of these? Functional isomer. What are these two?
Positional ice.
Is chain same? It's butanoic, it's propanoic. Chain is not same. So they are chain isomer.
This one's 2 that propanoid.
Yes, 2-methyl propanoic acid. समझ में आ गया पूरा? Take a break of 10 minutes. We continue at 3:18. I hope this is fine. बिल्कुल आराम से करेंगे इसको समझ में आएगा. Don't worry. We just new pen. Okay, shall we start?
Yes, sir.
Up to this, any doubts? Any queries? Okay. Where these two? Chalo, start करते हैं. Amines are primary, secondary, tertiary. We already know. How do you decide based on ammonia? And how many H we are replacing? For example, 1H is replaced, primary amine. 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 They are all examples of primary amine. Is that clear? If 1H is replaced, NH2 will be intact. NH2 part of as it is over. NH3 has become NH2 something. Right? What is secondary amine? When NH is intact. NH, 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 NH. Right? All these examples will fit in the category of secondary amine. Please note down all the examples. And tertiary amines are when you have nitrogen and there's no hydrogen. 3 CH3s. CH3 C2H5 pH. C2H5 CH3 C3H7. All these examples will fit in this category. Okay. That is the third situation. Wait, हो गया?
Right. I think 1 minute.
2 minutes.
Oh,
1 minute
One-
for 390.
Yeah,
said
370.
You said 380.
18%.
We just started. Primary, secondary, tertiary. Ammonia derivative. Just note on these examples. Primary case में NH2 will be visible. NH2, 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 NH2. Here, something NH2. Look at secondary amines. NH. Right? And tertiary amine, nitrogen, no hydrogen. So these are examples for our note कर लो speed में एकदम.
So you can have any carbon group.
Yeah, any group for
Okay.
that. So these are few examples that you can just.
Okay. So do we have like ketones and aldehydes and all that?
So is this part of functional isolation?
Yeah, again, very good question. I'll come to that also. That's why I brought this discussion. No, I'll discuss. First, you write down. Now, within the amines, primary, secondary, and tertiary are functional isomers. So थोड़ा यहाँ पे different. We don't consider primary, secondary, and tertiary amine as same functional group. I repeat my sentence. We don't consider primary, secondary, and tertiary amines as same functional group. They are called functional isomers. Now, this is not applicable for alcohol. You can't say primary alcohol, secondary alcohol is functional isomer. You can't say. Only in amines case we use this because we don't consider them as the same functional group. Okay? Is that point clear?
Technically, primary amines is a separate
Yes,
function.
yes. The secondary is different. For example, this and this, if you compare these two,
Like,
what are these? Functional isomers.
So
Why are isomers? Because everything is same there, right? 2 carbons, 1 nitrogen. They are functional isomer. Or these two, functional isomer. Okay? Or we can say,
and tertiary and primary also.
yes, and tertiary. Let's say you take this one and take this one. What are these two?
Functional.
Functional isomer. That's why I've written these examples. Okay? The purpose is that. Are you understanding? They are also functional isomer. What about this and this? all three of them are functional isomers of each other. See, I cannot randomly pick unless until the formula is matching, then only I can keep, right? Otherwise, we can't. So you can't say like this is also no, because this is 4 carbons. So we can talk about 3, 3, and 3. Make sense? If you want to take 4, then take 4 here also. 4 वाला यहाँ पे क्वेश्चन नहीं बना हुआ है, नहीं है, there is no such thing.
So why won't they be chain isomers or
Which one?
I know, suppose you take these 3.
Hmm.
Why can't they be chain isomers?
See, because what is definition of chain isomer? You have main chain, and on that groups are different. So function isomer defines better, right?
Okay.
Because you are having a different functional group, primary, secondary, and tertiary amines के बीच में bond करो. Right? So we'll learn about their IUPAC names for this and for this and for quaternary one, but that's a separate discussion. The basic part is clear. Okay. So primary, secondary, and tertiary are functionalized. It's written here also. Please check. Okay. They're functional isomer of each other. Primary is functional isomer of tertiary, tertiary is secondary, secondary is third. They are functional isomer of each other if molecular formula is same. If it is not same, of course not. For example, this compound and this compound, they both are primary. I can call it chain isomer because chain is different. 4-member chain, 3-member chain with 1 branch. Okay. What about this and this? 4-member chain, 4-member chain. NH2 in second, NH2 in first position. They are positional isomer.
So in a branch, if you put it here, it'll be this
Same
basically
thing,
the
it's a
same
linear,
thing.
yeah,
Only
correct.
in the middle it makes sense.
Yes, yes. If I put on the corner anything, it's not branch.
Okay.
Corner is never branch. Branch is anything except corner, right? Yeah. Please note down this discussion. This is important discussion. अभी easy लग रहा है, but बाद में मुश्किल हो सकता है, तो please note कर लो उसको पूरा. जो कुछ भी लिखा है पूरा note कर लीजिए. With example, and this discussion itself will give you clarity about primary, secondary, tertiary, or functional isomer, and what are positional
So
isomer.
what's that about MF is same by?
Molecular formula.
Molecular formula is same.
Okay.
Like it'll be an isomer, I think. No,
Yes.
draw this. At least this complete diagram. Shyam, is it fine? Shilpa, I can't see you. Niharika, I see you. Any doubt, Shyam? Conceptually, आपको समझ में आनी चाहिए क्या हो रहा है इसमें. Okay, now next part. Metamers in amines should be marked under secondary and secondary. Okay, you can mark only there. You are comparing secondary and secondary, but tertiary and tertiary. But you can't mark metamer between secondary and tertiary. That will not be metamer. Or primary and tertiary, or primary and secondary. Because if you try to do this, basically you are marking functional isomer. Understand this point? So note on this statement. Metamers in amines can be marked or should be marked
Same.
when the same amine you're choosing, right? Like secondary and secondary, tertiary and tertiary. Of course, primary cannot show metamers, so let's not talk about it, right? But secondary and tertiary we can't take, primary and tertiary we can't take, primary and secondary also we can't take. Easy? Sanjana, clear?
Yeah.
Good. छोटे छोटे पॉइंट्स, बट ये क्लैरिटी देते हैं आपके कॉन्सेप्ट्स को ओवरऑल, राइट? छोटी सी बात है, बट इफ यू अंडरस्टैंड दैट विल हेल्प यू आउट लेटर in certain question. Now, see this diagram. I have drawn two compounds. They are metamers to each other. 1, 2, 3 carbons. 2, 2, 2. 2, 2, 2 carbons. Can you observe? Number of carbons are 6 here and 6 here. Both sides 6. 1 nitrogen, 6 carbon. But they both are tertiary. So I'm comparing them. I can call them metamer because both are tertiary. And then arrangement is 1, 2, 3 and 2, 2, 2. Note down this example. This is example of metamer. Even this is example of metamer.
So within
2,
the,
2 and 1, 3.
like within this, if there's.
Yeah, if you make it branch,
Yeah.
it won't be metamer. Because metamer looks forward for different arrangements, not same number and different arrangement.
Okay.
So numbers can't be same. जैसे आपने यहाँ पे एक सी ऐसे लगा दिया, let's say, I understood out, you are asking this, right? Then in that case, what is the problem? It is a different chain altogether. I'll say this is 2 carbons. Here 1 carbon is hanging. I'll call it chain isomer, not metamer. But if you want to compare this situation with this situation, then they are metamer. Try to understand. This is 2, 2, 2 and this is 1, 2, 3. Still it is 1, 2, 3, no? So there is no restriction that 1, 2, 3 you have to draw like this. But you compare 3 and 3, they are not metamers.
Got it.
Okay?
Yeah, that I got.
Distribution has to change.
But-
Number of carbon distribution has to change. Like bottom line is this. If distribution is not changing, you are rearranging in a different format. You can't call it metamers. You can say chain isomer or something.
This and that won't be metamers, but this
Exactly.
and, yeah.
Yes. This and the current one and the new one which I have drawn, they are also metamers. Right?
Okay.
Yeah. Good. Next, functional isomer. धीरे धीरे मैं इंट्रोड्यूस कर रहा हूँ सारे आपको. So groups भी आपको पता चलते जाएंगे. Next is amide. Amide is also called acid derivative. लिख लीजिए यहाँ पे. Amide is also called acid derivatives. So what is acid? C double bond O, OH is acid. What is its derivative? If I put, let's say, Cl, if I put in place of this NH2, if I put in place of this OR, or if I place in place of this OC double bond O, these are all derivatives. Now the first derivative is called acid halide. Okay, or acid chloride we can say. If you want to put X, it is halide. If you want to put Cl, it is chloride. Is the name clear? So I repeat, R sample, right? Okay, start with the first carbon itself. First question itself. Try to draw these structures also. Among the given cations, which one is most stable? Now remember, carbonium ion or carbocation is the same thing. Okay, C plus charge.
What is that?
So I'm putting OH on carbon, and then the compound is primary ion. The first compound, propane. 2-methox. Jumbling number of carbons. If OC is hanging here in the middle, all right. You're having cold. Is it clear, Chinmay and Shyam? Not audible. Mic problem. Now come to this one. If I call this is A, this will be B, and these will be C. And this one I will not give any number or any alphabet. Why? Because it is 4 degree. What is 4 degree? Carbon connected with 4 carbons, right? Can you answer why I'm not writing, I'm writing A here